Right, so you want to pass the AWS Machine Learning Engineering Associate Certification, then you're in the right place, because over the next few hours, I'm going to take you through a mixture of hands-on practical, theory, and exam-style questions to help you get to grips with the exam content. All the code you need to run this is available for free on GitHub. The slides I will use for the theory, plus a handy revision guide, are available at the link below to download. On top of this, we will be doing exam-style questions throughout, links in the description. These are brought to us by today's video sponsor, Noza.ai. Noza.ai is an AWS certification preparation tool built by certified professionals for certified professionals. Noza.ai provides hundreds of AWS style certifications exams with detailed explanations and an AI learning assistant for more information. Link in the description to Noza.ai, where you get your first 10 questions free, and then there is a discount code for your first month's subscription with 20% off. I am a 15 times certified AWS professional and golden jacket holder, and I used Noza.ai to get the last few certifications over the line for that golden jacket. In terms of the exam content for the Machine Learning Engineer Associate exam, there are 4 domains. The 4 areas are data preparation for machine learning, ML model development, deployment and orchestration of ML workflows, and ML solution monitoring, maintenance, and security. This video will take us through all 4 domains with hands-on practical, with a little bit of theory, and then exam-style questions at the end brought to us by Noza.ai. Again, everything for this course that you actually need to run is available for free on GitHub, and then at the link below for the presentation slides and exam guide. What we're going to do next is look at SageMaker through a bit of theory, because we will be using it throughout this course and it may come up on the exam. If you're familiar with SageMaker, skip straight to setup. In the setup, we're going to jump onto the console and GitHub, spin up AWS resources, including notebooks that we're going to need throughout the course. Then we can get hands-on with the code from the GitHub repo. So join me on the computer and we'll do a little bit of theory on SageMaker. Before we get into the hands-on setup, I wanted to do a high-level walkthrough of what SageMaker is properly on AWS. Throughout the course, we will touch on different parts of SageMaker in context. SageMaker endpoints, pipelines. We'll be using Studio throughout to actually deploy our code. But I think it's really important just to spend 10 minutes now talking about some of the high-level features of SageMaker, and it will totally help you in the certification. First feature we're going to talk about is SageMaker Studio. This is a single entry point to the world of ML in SageMaker. Think of it as an IDE for AWS for machine learning. I'm going to go onto the console and show you what it looks like. So I'm on SageMaker right now. So I've just typed in SageMaker in the top and I went to this page. Once here, we click the hamburger menu and we go to SageMaker AI. It'll open a brand new tab. Don't worry about that too much. And then down the left-hand side in Application IDEs, SageMaker Studio. Don't worry, we are going to set this all up when we do the hands-on setup in the next section. I'm just showing you ahead of time of what we're going to do. So this is SageMaker Studio. This is a one-stop shop for everything to do with your ML. We have notebooks down the left-hand side. We have RStudio. We have SageMaker Canvas. We have the abilities to do models. We have SageMaker Jumpstart that we'll cover in just a little minute, experiments, jobs, pipelines, and deployments. If I want to deploy a notebook, I can click here on the left-hand side. I've already set up a notebook, and you will be setting up a notebook as well when we do the hands-on setup. So I can open it here, and I'll open our Jupyter Lab environment for us on a notebook. The key thing for the exam is to know that the Studio is a web-based IDE that unifies the entire machine learning workflow. If a question on the exam, and you can see here, is asked about a single environment to build, train, and deploy, you need to think SageMaker Studio, and we will be using it throughout this course. The next thing to know, and I just clicked on it as well, that you have notebooks and compute available to you inside SageMaker Studio and inside SageMaker itself. First, you have Studio notebooks. They run inside the Studio. They're backed by fast launching instances. They support IAM for single sign-on, and you share them with one click, and you can switch compute on the fly. You've then also at the moment got classic notebook instances, which is on the right hand side. I've grayed this out because they're not really used as much anymore. The recommended is to use Studio notebooks, but for the exam, you will need to know the classic notebook instances also exist. Exam tip, Studio notebooks are recommended. You can switch instance types, as in the compute that is actually backing the notebook, and you can actually then use the kernel and switch the kernel without restarting the notebook as well. So Studio, then into notebooks. Then it's important to know the training approaches that you can use inside SageMaker, and we will actually get hands-on with these training approaches today. The first is built-in algorithms. These are pre-packaged and optimized algorithms for AWS. We will be using the XGBoost model throughout our course today. The second is a script mode where you write training scripts from scratch. So you can bring your own code, you can bring your own libraries on top of it. We will look at some of the scikit-learn stuff today inside this course. And then the other option is that you bring your own container and then you use that. The exam tip, you will need to know which algorithm fits which problem. Later in the course, when we do the actual training models themselves, I will take you through a cheat sheet that shows you which model for which use case. So don't worry about this now. We'll look at it for later, but it's important to know that this exists inside SageMaker. We also will look at processing jobs today inside SageMaker itself. So processing jobs are how you run data for pre-processing, post-processing, and model evaluation at scale outside of a notebook. So productionizing your workflows. If I go back onto SageMaker Studio and I go down the left-hand side and you go to data preparation and you click on processing jobs, I have processing jobs here from running the course previously. You will end up with some processing jobs yourself throughout this course. This will currently be blank, but you can see that you can actually build processing jobs that help you inside SageMaker. And I said again, these are for pre-processing, feature engineering, model evaluation, and bias detection. We will be doing a lot of bias detection today. So when we're running that bias detection, you can come to processing jobs and see it in action. Next, we have the feature store. And the feature store is one of those services that comes up a lot in exam. It's a centralized repository for storing, sharing, and managing machine learning features. There are two storage modes that you need to know about. One is the online store, which is where you do low latency lookup in milliseconds, and the other is an offline store. We will be using the feature store today throughout the exam. We will be using the feature store today throughout this course, and our first ingestion script, we will create some machine learning features. On SageMaker Studio, when the time is right, when you're looking for it, it is in more, it is in feature store. You click on feature store and it loads. I have features already from running the course earlier. You will create these features throughout. You can see that we have a feature group, which is the housing features that we will create. And then we have labeled and created all the features for that group. Again, it's important to know for the exam, SageMaker has an online and offline feature store that lets you store ML features. This is data that you have engineered. You've took that data and you've done certain things to it through ingestion and transformation to turn it into machine learning features that you can use. When we're training models in production, we are constantly tweaking different hyperparameters, different data sets, different pre-processing, and SageMaker experiments let you track all of this automatically. An experiment is a collection of trials. Each trial is a single training run with its own parameters, metrics, and artifacts. You can compare trials side by side, and this integrates directly with training jobs. And again, back out in the SageMaker console, you can see on the left-hand side of Studio, within Studio itself, there is the Experiments tab. You can click Experiments. I have no experiments, but if we were to create some, this is where they would appear. Then for the exam, you also need to know about the model registry, which is the gatekeeper between training and production. Every model you want to deploy should go through the model registry. And here's how it works. You create a model group, and then it's a collection of model versions that specify use cases like fraud detection model each time you train. You can find the model registry again out on SageMaker Studio. If we go to models, and then inside models, once it loads, we can go to my models. And then inside my models, this is the model registry that I have created. We will create this during the course. And if I go to view latest version of that model, this is the latest version of that model inside the model registry. Again, you will not have a model at the moment inside the registry or the model registry, but we will be creating them throughout the course. For the exam, you will know that only approved models from the model registry can go to production when you register them with the flow. Again, we will cover this in the course. It's important to know for the certification that the model registry exists. This is where you train models, then register them in the registry. They can go to a pre-pending state, you approve the models, and then they can be used in production. SageMaker Ground Truth helps you create labeling jobs jobs. This is where you create a labeling job that needs to be done in order to verify your data. There are 3 options for then getting the data labeled if it is unlabeled. The first is AWS Mechanical Turk. The second is where you go to Marketplace on AWS and find a third party. And the third is where you set up your own internal workflows for your employees and yourself to label the data. This tends to come up on the certification, so you need to know that you can actually label the data in order to check your results. It is also really important to understand that SageMaker Clarify exists. This is where you actually look for bias and explainability within SageMaker. We will be using SageMaker Clarify today. It's important then to know that it exists for bias detection. Model cards are also documentation around the models, and these can be found on SageMaker down the left hand side, model governance, and then model cards. You click on this and you can see that I currently don't have any because I haven't created, but you can go in and create model cards for models that you are creating through SageMaker. And then this is how it all connects together. So you can use ground truth to explore and label data. You can use processing jobs to create and prepare the data. You can store the features using the online feature store. We then train and tune the data. We evaluate and track our ML experiments. We register and approve models that have been trained correctly, and then we deploy and monitor. And today's course, we will go through all these steps. And then this is the cheat sheet that you may need for the exam and definitely for this course, so we don't spend too long talking about SageMaker. You need to know that the studio is the unified IDE. The notebooks sit inside the studio notebooks sit inside studio. We've built in algorithms, processing jobs that we'll create today, feature stores that we'll look at today, experiments, model registry that we'll use today, ground truth, clarify that we'll use today, the debugger, and the model cards. So if you keep this slide handy, it will help you throughout this course. Okay, with that all being said, let's jump onto the AWS console and get all these resources deployed so we can do the hands-on part of the course where we actually create models, we do data ingestion, and we deploy those models to production that we can monitor and get that hands-on experience we need for the certification. Okay folks, I've put the full GitHub link in the description below that you will need to follow along. I'm going to go on screen now. I'm going to show you how to set up the AWS environment that we'll use for the entirety of this course, and then we'll jump back in and get into the theory afterwards. So I am on AWS, I am logged in, but the first thing we need to do is go to GitHub. I've put a link again in the description, and download the zip file because we will need a local copy as this as well as a remote copy. I'll just go to my download folder, I'll unzip that file, and I'll have the unzipped version sitting ready to go. Back on the AWS, we want to navigate to CloudFormation. So type in CloudFormation. And once there, we want to create a new stack with standard resources. We want to upload a template file. We want to choose the file. The file is in the folder that I just downloaded. So downloads, not in source data, but setup code. And then inside setup code, we want to hit OK. Then we want to hit next. And we need to give the stack a name, so I'm just going to call it the same name as the environment name to keep things simple. And then we hit next. We want to leave these as default, and we want to tick this radio box at the bottom because we are going to create an IAM execution rule for SageMaker. This is all just the defaults is fine, and we will hit submit. This will go off and start creating. It will take about 6-ish minutes to create. In the meantime, I think we just need to take a little quick look at the README file, just so you're aware. This is all the information on how to set up the environment, including the resources that we're setting up. Really important, this is not in the free tier. So this will cost somewhere around $3 to $6 to complete the course in one sitting. Make sure you delete all the resources when you're done. Back here, you can see all the information that we're going to output as well. I've also included the data, so we'll be using the housing data set and we'll be using the customer churn data set. This is what the data looks like. I will run over this in the tutorials as well, but it's good to have this information on the README. And then below, there's just a little bit about the exams themselves and the repo structure. We will also be cloning this repo into our SageMaker environment as well. So we'll be using it throughout the tutorial. So it's really good information to look through that README so you understand what we're doing. Right, let's take a quick look at the console. It's probably still creating. Yep, it's still creating as you can see right now. I'll pause the video and we'll pick this up once everything here has gone green. Okay, that took about 6 minutes in total. So the next thing we're going to do in terms of the setup is log into SageMaker and then set up a few things that we'll need. But before we do that, we will be needing the outputs that are in our output tab at all times. So I'm just going to keep this open on this tab and go to SageMaker in a different tab. Now, SageMaker has had a lot of changes over the last year or two. We're going to be using SageMaker AI. So that's down the left-hand side and then SageMaker AI. This will load and we should have a domain configured already. So you can see that we have one domain, one user profile. This is the user that was created by the CloudFormation script and we want to hit Open Studio. First time you've been in, it may take a few seconds to load, but it will spin up automatically for us. Just accept this at the bottom and then skip the tour for now. Now, the first thing we want to do is open a Jupyter Lab environment. So it's right here when I open today. It's also located in applications on the left-hand side. So I'll use the applications one. And the first thing we want to do is create a Jupyter space. So that's the right-hand side here and click. And we'll actually just create a public space to keep it easy. And today we'll call this the MLA-C01. And you have to keep it in within 1 to 62 characters, letters, numbers, and dashes only. 01. So the MLA-C01, create the space. This will go off and create the space. It can take anywhere between 30 seconds and up to 5 minutes. I have had experiences in the past where this has actually took up to 10 minutes. Also note, if we look on screen, I have kept it as default as the T3 medium instance. This is really important to keep costs down. We're not actually putting that much cost in. This way, it will stay between $2 to $6, maybe up to $8, depending on how long it takes you to complete this course. If you select a larger instance, it will cost more to follow along. So just be careful. Okay, so when that's done, you want to click Run Space. And you can see that we're currently updating. Please stay on this space. Okay, that took about 2 minutes for me today. And you can see that we're actually successfully created the app. You then want to click the Open Jupyter tab on the top left. This will open the lab for us. Again, take about 10 to 15 seconds the first time we do this today because it's literally loading it from scratch. Perfect. So what we now need to do is clone in the Git repo. So if we go to the terminal, which is down there on the left, and open a new terminal, you can see that we're in SageMaker user.default. We then want to go back out and the code is actually sitting here to clone it, but I'll show you how to do it from scratch just in case anything changes. So you want to go get clone, then back up here and you want to go to code and you just want to copy this URL for the HTTPS and then you want to paste that in. And in a few seconds, it will have copied in all the folders that we need. And if you just click that little folder icon, that one there, you'll see that we get the folders and then we have all the data that we are going to use and all the code that we're going to use for this tutorial. Now, there is one last thing that we might need to do or you might want to do, and that's update all the code in one go, which is by update the code, all in one go by changing your actual bucket. I am not going to do it. I'm going to do it per script because I want to take you through it step by step. So I'm not going to do this step right now. I'm going to do it step by step. And one final thing, when the time comes, we will need this at the top of our files to ensure that we're using the correct code. Again, I will take you through this step by step. And just one more reminder, really useful to look over this data page right now so you know what we're going to do through each one of the domains. So we have our VPC set up, we have our subnet set up, we have our SageMaker domain that we've logged into and copied the Git repo in, so we have all the code available to us. That's the setup complete. We can now carry on with the rest of the theory and the hands-on labs. Again, word of warning, make sure you tear this down when you're not using it. It will charge. It could be outside the free tier depending on your AWS account. Again, for me, it's costing between $2 and $8 depending on how long I leave the infrastructure up for to complete these parts of the course. Domain 1, data preparation. We could train the best model in the world, but if the data is not correct, it's garbage in, garbage out. Therefore, the exam focuses on data and data ingestion and preparation of the data. For the exam, you will need to know the different types of data format available in AWS, when to use these formats in line with your use cases, and then pick the correct format for the correct AWS service as well. Don't worry, what I'm about to show you in theory will cover all these aspects that you need to know for the exam. And then we'll do some demos at the end to get some hands-on experience with data ingestion, again, in line with the exam. So let's do a little bit of theory first, then let's get a bit of hands-on practice. Domain 1, data preparation. So, as I said, it is garbage in, garbage out. The model is only as good as your data. And before we build anything, we need to understand how the data is stored, where it lives, and how it flows into AWS. These are the most common formats, and you will need to know them for the exam. So the first one is a CSV file. It's comma separated values. I think everyone knows what CSV is, but it's important to remember that it's in a text format. It's easy to read. It's easy to work with. I am sure we have all used it in Excel at some point. But if your file is big, it is slow to ingest and use in everyday work with computing. That's because everything is text. All the numbers are stored as strings, it's row-based, and if you just want to read one column out of 100, you have to read every single row to get there. If we look at the data that we're going to use throughout this course, if we go into source data and we go to customer churn, you will see that it's in CSV format. So this is the large text file that we're talking about. This churn data is related to customers churning through a telecoms business based on the different products that they have. So be that like broadband that you're probably using now, mobile phone contracts, the amount of time that they've been there. We'll use this data throughout, but this is in CSV format, as you can see by the .csv. And this is what it looks like when we put it into a table format to read. The next format that you probably are familiar with and will need to know for the exam is JSON. So JSON format stands for JavaScript Object Notation. It's semi-structured, it's good for nesting data, and it's great when you need to use for web APIs. Again, many of my videos use JSON data, so this is what it looks like. You'll notice it by the curly brackets and then the nested schemas inside it. So again, important to know that for the exam. One that you're probably not as familiar with, but will need to know for the exam is Parquet format. I do have a whole video on Apache Parquet and using iceberg tables. So if you're more interested in diving deep, take a look at that. But the important things to know is that it's binary. It's columnar format, so it's not row-based format. We're into columns. We'll dive a wee bit deeper into that in a minute. It has compression, and we use it for analytics, data lakes, and S3. What also can come up during the exam is ORC format, ORC. It's binary and columnar. Again, it's used Hadoop. This used to be more present in a lot of big data systems, but Parquet has really become the gold standard. So it's important to know that ORC also exists as columnar format, but Parquet has really become the gold standard over the last 3 or 4 years. Avro is used a lot in streaming use cases, so it's row-based, it's binary, it has built-in compression, and actually it has a schema as well, like Parquet and ORC format, so it's really useful for streaming use cases. So if you're in the exam and you hear streaming, think Avro. And then Record IO. This comes up during the exam because it is used for SageMaker algos. It's how you can read bigger files quicker using SageMaker. It's row-based and it's binary, but if you have an exam question around ingesting data to SageMaker quicker for model training, the answer is most likely Record IO. You need to read the question carefully, but this is something you should always have in your head. And then pro tip, exam tip, Parquet is the gold standard for analytics on AWS. So just a bit more of a deeper dive here so you're well aware of what's going on. CSV is human readable text format, row-based, stores numbers as strings. And then we have JSON over here, which is semi-structured and needs nested data or supports nested data. Small files, Excel, quick imports, API, nested data, web services. Again, need to know that for the exam. Now, a bit of a deeper dive into Apache Parquet. Parquet itself is column based, and that's important for analytics because if I want to get the sum of everyone's ages and the age column is this orange column, then with Parquet I can just go read this orange column in effect, and the rest of the file I do not have to read. If we go over to a row-based format CSV like here and it was still the third column, if I wanted to read everybody's age in these 4 rows, I have to read all 4 rows. I cannot just jump straight to this column. I have to read all 4 rows. I must read everything row by row. I only need to read the columns I need, or I only read the columns I need when I use Parquet, and that's why it's important for analytics. As you can see, it's compressed by default. It's faster than CSV when it comes to those columnar analytics, so sums, averages, ranges, and it's the gold standard for S3 data lakes. So it's important to know when you're building a data lake for the exam or you want to ingest large analytical data for the exam, you should think Parquet. Quick bit on Orc, Avro, and Record IO. Orc is basically like Parquet format, but you need to know both exist for the exam. However, as I said, Parquet is becoming the more of the gold standard. Avro is for streaming, so it's row-based, it's serialized, and supports evolution support of your schema through streaming. Great for streaming, used with Kafka Kinesis. For the exam, if you're thinking streaming data format, think Avro. And then Record IO is SageMaker's preferred format for ingestion of data. It's AWS's native format for SageMaker. So again, during the exam, if you think you've got a question about SageMaker and data ingestion and the speed of the data ingestion, and it gives you the option to go to Record IO, you should be thinking Record IO. This is then what I've said in summary. So this is a really good slide for the exam. You really need to know this because we will get questions. Analytic queries of subsets of columns because it's columnar format, Parquet. Avro for streaming, Record for SageMaker, CSV when it's simple imports, Parquet format for your data lake. So again, this may come up during the exam. JSON for when you're building web APIs, particularly doing real-time inference. And then Orc comes up, as I said, for Hadoop and Hive ecosystems. It's exactly the same as Parquet in terms of its use cases, just Parquet is more now the gold standard. Then for the exam as well, you really need to know this table. It comes up all the time. So S3 is your gold standard for building a data lake. Data lake is where we keep the storage of data separate from the compute. The cost is low, the latency is high. So this is where we would store large volumes of data. There are plenty of videos on this channel about building data lakes. If you want to know more, go look. But for the exam, think S3, object store, lowest cost, highest latency. It's where we build our data lakes. EFS is a file system, so higher cost, lower latency, shared across multiple tiering jobs. FSX on top comes in as well as the highest cost, lowest latency. Important to note if you need it for migration reasons from on-prem. RDS is our relational databases, so this is where we store our relational data. Postgres, Oracle, Microsoft SQL Server, all available. And then DynamoDB is the NoSQL data lake or NoSQL database for key value or document lookups on AWS. So it's serverless and AWS look after. For most ML data lakes, S3 during the exam is probably the answer. It's important to know about EFS if you need it for low latency. RDS is important to know if you have relational data and you want to store it in a relational database. And Dynamo is important for key value. But when they talk about ML data lakes, machine learning data lakes in the certification, they are mostly talking about S3. Take your time, read through this slide, make sure you understand it. And if we dive a little bit deeper into S3, it's important to know that it is infinitely scalable. The cost of the storage is the cheapest per gigabyte or per megabyte stored versus the retrieval cost. So cost versus latency, S3 is one of the best, and it integrates pretty much with everything on AWS. Pretty much everything for the exam where there's an integration point with AWS, it's important to know that S3 can do it. It stores raw data, you can store your process data, the model artifacts that we train out of SageMaker will be stored there, the training data sets are stored there, and even our feature store for our offline feature store will store there. We will cover all these during the course in depth. In our practical examples, we will be creating an S3 bucket. We will be storing raw data. We will be storing our model artifacts. We will be storing a feature store offline on S3 as well. Then during the exam, you will need to know a little bit real-time in streaming because you might want to do some real-time model inference. So Kinesis Data Streams is a fully managed streaming service. MSK for Apache Kafka, so that stands for Managed Service Kafka, Managed Apache Kafka Service. Manages Kafka on AWS, where AWS look after the installation and the uptime of Kafka, but you still have a lot of hands-on around both all your broker nodes and your master nodes. It's higher throughput than Kinesis data streams, but there is more hands-on, so it gives the flexibility to customers that they need. And it's important also for the exam to know about Apache Flink, which allows you to stream data and then batch it or aggregate it. So usually what you would see is something like Apache Kafka is doing the real-time streaming, bringing in single records. Then it goes to Apache Flink that groups and batches those records together, maybe every 5 minutes, maybe every 1 minute, and then those records go into SageMaker or S3, something downstream. So usually what you see, data source, Kinesis Kafka, Flink, S3 analytics. So that's the flow you need to know for the exam. Data source comes in, records, single records usually on Kinesis or Kafka, depending on what your streaming needs are. Then you go to Flink. Flink does some processing, some aggregation of the data, some sliding windows, batches it up, and then sends it to S3 or the analytics. And for the exam, you'll need to know that flow down the bottom. Batch ingestion, you can see that there's Kinesis Firehose. This is where you stream data into Kinesis Firehose. It batches the data up. You can do some transformation, and then every 60 to 900 seconds, it delivers that batch of data down to S3, and it converts it to Parquet automatically with zero administration. So again, in the exam, if they're talking about batching data and they want to do it through a streaming mechanism, think Kinesis Data Firehose. And then you always have the handy direct S3 upload. This is where you can just upload data to S3 directly. That could be automated as well. So important to know that you have the app or the file, Firehose or CLI, S3 bucket, S3 event in the training. But for the purposes of the actual exam, it's important to know for batch ingestion, Firehose, direct uploads. And then for the exam, you will get questions when you need to pick a streaming ingest over a batch ingest. So this slide I've put together just to give you that overview. So Kinesis data streams, Apache Kafka, MSK, managed service for Apache Kafka, Apache Flink is available within 5 minutes. Real-time dashboards, continuous data flow, think streaming. Daily batch at midnight, training can happen anytime. File arrives once a day, think batch. Streaming, batch. And then putting it all together, this is what you would see in the exam as a scenario. Ingest 10 gigabits per hour, available for all ML training within 5 minutes. Well, you need to be thinking streaming. Therefore, if there was an answer that said Kinesis data streams plus Parquet on S3, that's what you would choose. Then daily batch file at midnight, training whenever convenient. So we know that these buzzwords, we're looking at a batch, we're looking training whenever convenient. Therefore, we could direct load up the S3. S3 would do an event notification, and then SageMaker could pick up the training when it wanted. So, real time, batch. And then finally, the key takeaways for this, Parquet for analytics, Avro for streaming, Record IO for SageMaker. That will get you quite far in the exam on itself. S3 is your default for the data lake. It's cheap, scalable, and integrated. So when you see data lake and ML, think S3 for the exam. Streaming, Kinesis or Kafka for real-time, batch S3 upload for a schedule. So just think streaming versus batch. And then you need to match the scenario to the tool. So if it's talking about daily uploads, you need to think about batch. If you're talking about 5-minute intervals, 3-minute intervals, 2-minute intervals, you're thinking streaming. And then just a quick word before we jump into the demo. We will be using this churn data set quite a lot. Again, just to explain what this is a number of customers during a telecoms provider or with a telecoms provider. And then we have attributes about those customers, about their gender, their age, is there someone else in the household, their types of contract with the provider. Do they have a phone? Do they have multiple lines? Do they have internet, online security, tech support? What type of contract they have? And did they leave? Did they churn through the company? Yes or no? And then what we're going to do is build different prediction models on this data to predict who will churn and who will not churn, or how we stop people churning through the company, how we stop people leaving us as a telecoms provider. This data set is very, very widespread when it comes to analytics models because it's very easy to understand. So I've kept things in line with that throughout this course. Okay, so for the demo, we're going to use our notebook environment. So again, I've got it loaded already, but if you don't, navigate to SageMaker AI, go to the dashboard, and then open Studio button with the user selected. You'll land on the Studio that looks like this. Then you want to go to the space that we just created for the Jupyter notebook, and you want to go Open Jupyter Lab. So again, if you land on this, and it looks a little bit like this, you'll have the recent spaces, and then you want to click Open, that is there. I already have it open on a separate tab. It will bounce into that separate tab, and this is just the terminal that we set up earlier to copy the code. Perfect. So what we want to look at first is the number 2 data ingestion code, and then we just double click into it for now. There's a couple of things we need to update here, and I mentioned that I wasn't doing the find and replace all because I wanted to run you through it. We've imported the Bodo3 library. So the Bodo3 library is really important for AWS. It is the Python library that lets us interact with AWS services, and we use it all the time in machine learning engineering because we constantly want to interact with other AWS services such as S3 in this example, and eventually the SageMaker feature store that we'll see as well at the end. Then standard libraries like pandas and numpys. This one is probably different that you may have saw before. We're importing the SageMaker library as well, so we can use a session from SageMaker. And then from the SageMaker library, you can see that we're also importing the feature store, so we can actually create feature groups as well. So these are the things that we do need to update for our data. So let's have a little look at what we're doing here. So we want the bucket name, the region, and the role ARN. So that's the SageMaker role ARN. Now, if you remember, I asked you to keep your CloudFormation open on the Outputs tab. If you have lost this, then it's easy to find. So just go to the top and go CloudFormation. Then you want to go into your stack and you want to go Outputs. And it has all the information we need sitting right here. So let's look at that information again. Your bucket name. So we go down the left and you can see S3 bucket name. Your bucket will be different to my bucket, as is the way of AWS. And then you just want to copy that in. Get rid of that, but keep the quotation marks. Perfect. Our region, I am operating in US East 1. You'll be able to find out on the top right of where you set it up. So all these scripts I've created are working in US East 1. I'd advise you to use the same region if possible. So you want to go to US East 1. And then you need your SageMaker role ARN. So this is the SageMaker role that was created by the CloudFormation script. SageMaker execution role ARN. And then you just want to copy that and you want to paste it back into where it has the placeholder. So just get rid of this and place it in like that. Then Control S to save, just so we have a saved version of this code. Right, I'll run you through it and then we can take it out and we can see it in action running. So let's have a little look at what the code's doing before we do anything else. This is the import of the S3 SageMaker feature store Bodo session that we'll need. Step 1, upload the data to S3. So S3 is a good default data lake, and I've put hints through these code as well so you can see what we're actually doing. We're going to actually upload the data into S3. That data, and if we just take a little second, we go out, it's coming from here. So this is the source data, and we're going to look at the housing data first. So you can see here that we're going to upload the local housing data and the local churn data. But that housing data looks like this in CSV. So it's about where the houses are, what they've been sold, the population, number of bedrooms. Again, if you need to see it in another format, out on this README on the GitHub, I have also listed it so it's easier to read. But we're uploading these S3. Now, if I just go back one more, go back into the data ingestion and go back to the code, which is open on this tab, then have to do that. You can see then that we uploaded the data to S3. So we're taking a prefix as well that we're specifying for this load. So you can see we're using prefixes to organize raw, process, train, val, and test. And we're also enabling versioning on the data as well. We're then going to read the data back out of S3. We're actually using, as you can see, Bodo3 under the hood. For large data sets, use SageMaker processing jobs instead. Parquet format is preferred for large data sets. We're using CSV right now. That's okay. Organize data for training. So we're going to take the data and we're going to split it into train, validation, and test in S3. So we're going to read the data up from S3 and put it back to S3, having split the data set up. That's really, really important. We're going to split that data set up. Step 4, we're going to then do some feature engineering where we're going to create a feature store and we're going to create features out of that data that we have already then put back into S3, and we'll see that in action once we run the code. And then we ingest the data into the feature store, which will have an online version and we'll have an offline version that we covered in the theory. And then we'll show you how to query the data as well from the feature store. And then this is just a little bit of exam knowledge that I'm going to print out at the end when we run the code. Right. Then there's a cleanup, delete feature store, and upload S3 data. And we also have the main as well. Right. So what we need to do next is we want to copy that code. Actually, we'll leave the code open. This will be easier. So we'll just go back into the main home directory. And then we want to I hit the plus button and we want to start a new Python 3 kernel. Now, we need to set one of the directories. So if you go back onto the README, we want to take this line here. This is really important. We need to put it at the top of every Studio notebook that we're going to run. So this is a Studio notebook. Again, this may come up in the exam. It's good to know these are notebooks, Jupyter notebooks that we can run code in. So there it is. And then we just want to hit run, which is this little play button. And then that has set the directory for us. If we quickly jump back into the data ingestion and where we have updated everything, we want to copy that and we want to paste that all into a new cell itself below. So that's one cell. This is the second cell. And then we want to hit run and we're actually going to execute that code now. So if we go quickly back up to the top, you'll see that there's a star, which means that it's executing. That asterisk means that the code is executing. I'm going to scroll back down to the bottom because I've got everything printing out for us as well, so we can see it as we go. So you can see here then this is the demo. You can see here the first thing we're doing is uploading that data into S3. You can see that we're putting it under a raw data format, so we're going into that raw folder. Step 3 is we read the data up from S3, and I've asked it to print things out so we can see it like this. So there's some information about what we see. There's the columns. There's the shape of the data as well, which is one of the outputs that you'll get asked about, shape data. We then organize the data for training. So we have training channel, validation channel, and test channel. And you can see there quite clearly we have 35 rows, 7 rows, and 8 rows. This is a smaller data set, but it's good to understand that you need training, validation, and test data when you're going to train models. And then we actually create feature group columns as well, as you can see. You then create the feature group itself, and then we have an online and offline feature group, and you can see that the feature group is active and ready. And then this is just a little bit of exam information I printed out at the end, so you know the different formats of data required for the exam as well. Now, it is really important to understand the difference between an online and an offline feature store. So let's quickly go on to our SageMaker feature store and take a little look. So to do that, you want to go to your SageMaker Studio tab. You want to go more and you want to go to feature store. And we will have now a feature store running, as you can see, both online and offline, although you won't be able to see that quite yet. If we go into the feature store itself, it looks like this. So you can see the features that we have created, the data that we have manipulated for machine learning purposes. We have the details of what's going on and how we are looking at it as well. You have things like the table format, where it lives in glue, and you have the online settings down here because we have an online feature store and an offline feature store as well. And then you can look at the lineage of the feature store as well, which is really important. So you actually know what happens to your data over time as you evolve those features within machine learning engineering. Now, it's good information to know that although this feature store looks like one UI, there are two things backing it. There is an online feature store and an offline feature store. The online feature store is DynamoDB, where you look up things in milliseconds of latency, really important when you need those features in real time. And then you have S3, which acts as the offline feature store. This is where we would do more training type exercises outside of our production workloads. There are some nuances to that, but what you need to know is online feature store is backed by DynamoDB for millisecond latency, and the offline feature store is backed by S3. Really, really, really important information. Right. The other thing that we might want to just take a quick look at as well is that S3 bucket, because it's good to understand how those files were uploaded, split out, and what we were looking at. So click on the S3 and then go find the bucket. So mine says ML course. And you can see the first thing is we have this folder MLA-C01 created. This is where the raw data sits. So these are exactly the same exactly the same CSV files as that are sitting in this data set here. So the ones that are in source data, housing, CSV, these are exactly the same files. We've just uploaded them to S3. And the same goes for the housing data and the churn data. Then if I go back up to the top of the bucket and I go into feature store, this is where it gets more interesting. These features are the ones that were created by the script. So we have an offline feature store sitting here that was created by our Python script that was running inside our Jupyter notebook as well. And if I just go back up one more and I go into channels, this is where we've took the housing data and we have split it into test, train, and validation data sets. So we split it up into 3. And if you remember back to the code, we asked it to do that for us, and I'm just looking for it right here, step 3. So we've got a training data, so one file has 35, a validation channel has 7 rows, and we have a test channel that has 8 rows. Again, small data sets, but important to know what's going on for this. So we've looked at the S3 bucket, we've looked at the raw data that's been uploaded using our Python code. We've looked at the training channels that we created as part of that code as well. We've looked at the offline feature store inside S3 on top of that. We've looked at the online feature store through the SageMaker console. And we have also looked at the shape of our data, mean of our data, types of columns as well, doing that exploratory analysis. So that's the first bit about how we ingest data, how we look at the shape of data, how we create a feature store. Let's move on and look at transformation of data now. So we've now ingested the data. We've got it into AWS. But real data is messy. So in this next section for the certification, we're going to look at how we transform that data, and we're going to look at how we turn that data into features through feature engineering. We'll do some theory first, and then we'll get into some practical scripts that you can follow along with using SageMaker. So let's jump on and look at some slides. So real data is horrible. It has missing values, so we might have 99% of the columns are complete with 1% gaps. It has outliers, so data that doesn't make sense inside its valid field. We could have an age range. It could have an age up to 150. We know that's not possible for human beings, so we can have issues. And then we can have different scales within the same data set. Some of the data goes from 0 to 1. Something measuring the same thing could go 0 to 100,000, and we need to normalize that to make it the same. Handling missing values for the certification, you will need to know when this to use, what ones to use, and how to use them. There are cases with missing values where you may just want to drop rows. This happens quite a lot when there's a very small percent missing and you can just lose those rows. Mean and median do come up in the exam as well. So the mean is where you want to take the middle or the average of the results and replace it with it. And median is where you take the middle of the results and you want to replace it at that. Con is you're adding artificial values, but pro is it preserves the data size. So this is pretty good when you're missing at random. Forward fill is where you use the previous value in a sequence to then actually get the next value in the sequence. So that's for sequential data. And then fill with 0 is where you actually just replace with 0 explicitly when data is missing. So you can see here during the exam, you may have to choose from one of these methodologies in order to find the missing values. Important to know this slide for the exam, and you're able to recall when to drop rows, when to use mean and median, when to forward fill, etc. Dealing with outliers. So outliers are when things fall without the expected range or things that are outside the expected range. The most obvious one is just delete. So if the data is just wrong, just delete it. You can cap or clip the data. So this is where you set a floor and a ceiling. So you might say that 99% of the data is less than 100. You have outliers at 10,000. So just cap at 100 and then you just push those outliers away from your data set so you don't use them. You're basically clipping and capping the data of where it needs to be. And then the last one that you will need to know for the exam is when to apply a log or a square root to compress the range. So you can actually compress the range of things using logarithm transformations. So for the exam, you will need to know when you want to remove, when you want to set a floor, or when you want to actually skew the distribution, squeeze it back in into an applicable range using a log transformation. Scaling and standardization, so just a little bit more about this. So why? When you feature A from 0 to 100 and feature B 0 to 100,000, the larger scale dominates the model. So if you've 0 to 1 and then 0 to 1,000, it's always going to look at feature B influencing the model more heavily than feature A, and that's not what you want. So you can normalize that back down into a range that makes sense between 0 and 1 using normalization, or you can use standardization where you actually look at how you handle those outliers better, where basically you pick a mean and then you pick how far away you want the data to be from that middle value. So normalization and standardization, two important procedures that you may need, functions you may need on your data to stop one feature having more of an influence than another feature based on the scale that it is dominating in. Encoding categorical variables. This does come up as well on the exam, so it's important to know. I like this example of the color, so I'm just going to run you through it. So I'm going to start on the right hand side to look first, so label encoding. We have colors red, green and blue. So the obvious thing to do when you're using a model, because it can't read text, is to make everything into a number. But if I used 1, 2, 3 in this example to code red, green, blue, the problem is that there's order implied. If I do 1, 2, 3, red is greater than green, green is greater than blue. That's not true. So instead, you can use a one-hot encoding. This is where it takes the color column, takes the values in that color column, turns them into label heads, and then does a binary 0 or 1, true or false, for each one. So color red, red is true. Color red, green is not true. Color red, blue is not true. Green, red is not true. Green, green is true. Green, blue is not true. And then blue, red is not true. Blue, green is not true. Blue, blue is true. And this is important because it doesn't imply ordering amongst the variables, but it creates sparse columns. That is the downside of it. It actually gets more columns added to it, so there's more data to compute, but it's safer for most models. One hot is safer. It does not employ ordering between categories. This comes up on the exam quite a bit. So you'll need to know that one hot encodings when you do this split around the columns. And it makes sense because you do not want ordering in your columns based on the numeric data. Will come up in the exam. Important to know. So here's another example. We will be using the house data set during the exam. We already ingested it, or during this course rather, we already ingested it. But you can see if we look at the size of houses and the price of houses, here is how you would one hot encode around the price. So you have the ID 1234, they have price 250, 420, 180, 310. And then we're basically saying the price in London, this column is true. The price for a large house in Paris is true for this. The price for 180 in London is true for a small. And then the price of 310 is medium, and in Berlin is true there. So there's no ordering implied that London is greater than Paris 1 and 2. So the model chains each city independently. And here you can see then it's the city is 3 columns, the size is 3 columns along the top, and then we're just putting it in line with the price. So that's how you one hot encode variables rather than giving ordering to them. Again, important to know this for the exam. Binning and log transformation. So binning will come up as well in the certification quite a bit. This is where you have continuous categories that might have age, for example. And what you do is you put a range in, and then you bin them into categories. So not the 18 years of age would be youth, 19 to 31 is a young adult, 36 to 55 is middle-aged, and then 56 to senior plus is senior. And this is rather than having a continuous thing like age of not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this helps models learn non-linear relationships. And there's different ways you might want to bin ages to influence the way your model comes out. So these categories might be too broad. You might want to go 0 to 9, 9 to 18, 19 to 25, 25 to 35, and that's all part of feature engineering, working out what these categories need to look like in order to give you the best results of your model. And then the other thing that you will need to know for the exam is the log transformation. So this is when you have data that's skewed and it spreads out a lot. A log transformation will squeeze that data back down into a more normal range. It's also useful when you have many small but lots of purchases, so they're all spread out by a customer. Binning comes up on the certification quite a lot. Log transformation, a bit more sparse, but it's important to know what it is. And then these are your feature engineering toolkits. So these are the things you'll need to know. Normalization, as we talked at the start, is where you bring things on a scale of 0 to 1 from whatever range it is. Standard deviation or standardization is where you take the mean and then you take the standard deviation from the mean. One hot encoding is those tables where you take categorical data and you turn it into binary columns rather than using just pure numeric columns, so you don't have ordering implied. Label encodings where you take categorical values and turn them into integers. Binning is where we take continuous things like age and then set them in the range of categories. And then log transform is when we compress skewed data. So if you know this slide for the exam, you'll be doing very, very well, because you just need to know when to pick each one of these as a feature engineering task. Now, onto the AWS side of things. Which tool do you use and when? So for the exam, when you're doing feature engineering and data ingestion, you will hear Data Wrangler come up, you will hear Glue come up, you will hear Glue Data Brew come up, and you'll hear Jupyter Notebooks come up as well. So SageMaker Data Wrangler is a UI, so it's pick and click and point. So when you need something that you don't want to code and you want to drag and drop and you need a visual, you should be thinking SageMaker Data Wrangler. AWS Glue is for serverless ETL. It can do PySpark and PyCode and scales horizontally for large data sets. So that's important. Large data set ingestion, think AWS Glue. Also, when you see serverless ETL, also think AWS Glue for the certification. AWS Glue Data Brew. So this is a point and click data quality tool and helps you build ETL and anomaly detection pipelines outside of Glue. It uses reusable recipes. So this is more about point and click in Glue. This is about building reusable ETL pipelines. And then your Jupyter Notebook, which we've been running inside SageMaker, is where you want to write Python code. It is simple and flexible, great for prototyping, pandas, and scikit-learn. Again, you just need to know this information for the exam. What is SageMaker Data Wrangler? What is AWS Glue? What is AWS Glue Data Brew? What is the Jupyter Notebook? And when do I use them? Serverless ETL, I use Glue. When I want to do a point and click UI inside SageMaker, I use Data Wrangler. When I want to look at more data quality focused things with a point and click motion, I use Glue Data Brew. When I need a flexible notebook to write Python code, I'm going to the Jupyter Notebook. Those are the type of questions for the exam. So that's what I've laid out for you here on this slide. I've actually give you the whys, whats, and whens of each one. So for Data Wrangler, Visual Explorer, and build transformations. Process terabits of data hourly, think AWS Glue. Data quality checks and anomaly detection, think AWS Glue Data Brew. One-time transformations in small teams, think Jupyter Notebooks and Pandas data frames. That's one of the Python libraries. Serverless ETL, then you want AWS Glue. Rapid prototyping with Python, you need to think Jupyter Notebooks. No-code data preparation workflow, think Data Wrangler. Learn this slide for the exam. It will be extremely, extremely helpful. And then this is what the transformation pipeline looks like for feature engineering. You want to handle your missing data. You want to remove your outliers. You want to scale and normalize that data. You want to encode the categorical values, and then we turn those into engineering features. Data starts very raw, it's messy, it has outliers, and then we're taking it through this pipeline and we're producing clean, scaled, and coded features ready for model training. So the key takeaways here is that context matters. You need to know the outliers and how to remove them. You need to be able to scale your features from normalization. One-hot encoding comes up a lot on the certification, so spend some time understanding what that is and looking at the tables. And then you will need to know when to choose what tool and when. So Data Wrangler is visual. Jupyter Notebook for prototyping. Glue for scalable ETL serverless code. Things like that. That's the key takeaways. What we're going to do now is jump onto the AWS console and use the Python notebooks that I've created as part of this course to look at different models or different ways that we can actually create normalized data inside SageMaker. Okay, so again, I have all the code ready for us. So inside the data transformation, we want to look at the data transformation py file. Again, we're importing things that you've probably saw before. The pandas, the numpy. The Boto3, as I explained, is the library for AWS and Python to interact with AWS services. This may be new as well. We're introducing the scikit-learn library, which is one of the model prediction libraries in AWS. Again, we need to actually configure a few things. Here you can see we need to change the bucket name again. So if I delete that and go back to the outputs and go to my S3 bucket name, we'll just copy and paste that in. And then the region, again, I'm in US East 1. You'll need to update this to the region you're operating in. My advice is to use US East 1. You can see then that we're going to use the local churn data and we're going to use the processing churn data. So the first thing we do is we load up the data itself. We're going to look at some of the statistics of the data. We're going to look at missing values and we're going to look at the distribution of the data as well. We're then going to handle missing values, which is really important because you will need to know these for the exams. In the exam, this did come up with me, how you hand missing values, how you actually encode values that are missing, be that through the mean, the mode, or other ways that we will cover. So spend some time reading through this and looking at how you can manipulate data to fill in missing values. Then we remove duplicates. This also comes up in the exam sometimes. Like, is there a drop duplicate function that you can use either through Glue or PySpark or Python? So really good information that you know you can drop duplicates as well in the code. Then we're going to do some feature engineering as well. So we're going to be more impactful in the model selection. So you can see that we're going to do binning, we're going to do log transformations, we're going to do interaction features, and we're going to do ratios as well. So this again is like binning, where you're actually taking values and then binning them together. So 0 to 12, 13 to 24, 25 to 48, 49 to 72, 72 plus, basically, because that's our bins that we're going to use throughout rather than having the individual labels. You can see then we do some encoding of categorical values. So this is where we take like the original categories of low, medium, and high and then use tree-based models to handle them directly. One hot encoding. One hot encoding came up a few times on the exam as well for me personally. It may come up on you. Worth spending some time looking at one hot encoding. Require linear models and neural networks. So this is where you actually want to take nominal characters that have no order, like gender and contract types, and then do one hot encoding on them as well. And then we're going to do some binary encoding as well. So yes, no, male, female, how does that look like when you encode it? This will all print out, so we'll go through it, but really important again, we're going to do test, train, and validation split when we actually look at this data for ingest, and then we're going to save it to SageMaker for training, which is really important because we're going to need that information. So to run this again, let's just copy this out. You'll want to go back to the Python notebook that we used before because it's in the home directory, so it's really important we're running it from this directory, and it's already set up to run across that import. If you've lost this notebook for whatever reason, then just start a new notebook here by hitting the plus button when you're in this directory, and then you will need to copy across again that piece of code that I have put in the readme here so that it's set up correctly to read from the files. Grammarly can go away right now. Yep, and then we just want to paste that into a brand new cell and we want to run it, and you'll start to see information come out as well. So there's the shape of the data, there's the columns of the data. I've printed out the first 5 lines here so we can see it. Here's the numerical summary of what we're looking at. That's really, really important as well. I'm just going to spend a little second on the one hot encoding because I think it's really important because it does come up a lot. So when we look at the data, we have information about near an ocean proximity for the house itself, and it has information that says like near land, inland, near bay, sea view, things like that. And what we want to do is turn that text information into numerical information for the model to read. Now, if we were just to encode it 0, 1, 2, 3, 4, 5, the model would think that there is weights or influence associated with the numbers, which in this case isn't true. We're just trying to get data that is textual into numbers. So in this case, one hot encoding will create an extra 5 columns, and then it will just be binary yes or no for each one of those new columns, which is near bay, ocean view, inland, etc. I'm just going to scroll back up just to show you something as well. It's also really important to understand that when we're doing some of the insert of the data that we're using the median and not the mean, because the median will skew. So here when we're doing the missing values, we are going to use the mode, or we're going to use the median. We won't actually use the mean because the mean will actually skew our data for us as well. And then lastly, if I go back down to the output, you can see that we changed the data like this. So you can see that we've created a training data set, a validation data set, and a test data set as well. Really, 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 really important. And then for the one hot encoding here as well, you can see that we've actually created 75 extra columns to take this information of categorical values and turn it into data values that don't actually have any implied meaning in terms of the order, but it's created 75 extra columns just to do this for the one hot encoding as well. Next, we're going to take a quick look at an ETL script for AWS Glue. I'm not going to execute that script because it would involve standing up Glue and going through a lot of process that could take us 10 or 20 minutes. There are lots of videos on this channel about AWS Glue. It is one of my specialties. If you want to deep dive in more, just check out any other video on this channel, including the exam prep for the Data Engineer Associate course at AWS. But let's just take a quick look on the console. Actually, we'll look at it on GitHub so you understand how ETL code is created for AWS Glue. So it is in the data transformation folder. It is the Glue ETL job, and it looks like this. There are a couple of things that you may need to know for the exam, so I'm just going to point them out. In the import section, you can see we're importing AWS Glue and different libraries belonging to AWS Glue. So obviously required to do AWS Glue. And the other thing that you'll notice as well, we're importing some PySpark functions as well. So AWS Glue can run Python and PySpark. Important to know that for the exam. We'll scroll down into line 40. And you can see that these are the arguments for AWS Glue. So you may get asked in the exam about how you input arguments into AWS Glue, such as job name, S3 input path, S3 output path. These go in as get resolved options. Again, may come up in the exam, so it is good information to know. Then in line 59 here, you can see we're doing some imports. So Spark context is how we enter a Spark session in AWS Glue, or Spark sessions in general. Good to know for the exam. Glue context is how we put a Glue wrapper around our Spark context. And the Glue context gives us access to different AWS libraries or interactions such as S3. Again, may come up in the exam. You need to know what a Glue context is. It's how you wrap Spark context in Glue context to get access to AWS services. Down line 74, you'll also probably need to know that you can get dynamic data frames out of Glue with options. So that's what's happening here. A dynamic data frame is Glue's version of a data frame. So if you're familiar with pandas, then it's the same sort of thing, but it handles messy data more gracefully. It also gives you interactions with other parts of AWS out of the box that you don't get with Panda data frames. So a Glue data frame or a Glue dynamic data frame is similar to a Pandas data frame, but with AWS flavors wrapped on top that make it easier to interact with. And then lastly, let's just take a quick look at line 189. Down in 189 here, you can see that we are writing the data frame down, and you can see that we're writing it to S3, and more importantly, you can see that the format is Parquet. So we're writing it with Parquet with partitioning on price category and size category. This may come up in the exam. You may be asked questions around partitioning, and you will be definitely asked questions on data types such as Parquet that we covered already. So it's important to know that using Glue, you can write the S3, you can partition that data, and you can actually use that from a dynamic data frame that you've imported from the Glue context. So again, important things to know for the exam, but we're not going to execute the code here. If you want to dive more deeper into Glue, or you're not familiar outside of these concepts, plenty of videos on the channel. So to recap what we've just done, the first section of code that we executed in the notebook is doing data transformation in the notebook, more like what a data scientist would do day to day, and we did that through the Pandas data frame. The Glue code that we didn't execute due to time constraints is doing exactly the same thing pretty much, but using AWS Glue. In the exam, you may be asked when to use one over the other. So AWS Glue is great when you're working with petabytes of data that needs partition that you're doing daily runs on repeatedly. And you can also save this to a feature store the same way that we've done previously with the data. On the other hand, operating in notebooks brings it closer to your end users of data engineers. This is quite useful when you're doing discovery work, when you're yet to build those production ETL pipelines for repeated processes. So for the exam, you will be asked questions on when to use SageMaker processing, when to use Glue processing, when it makes sense to do one over the other, what is the data type such as Apache Parquet that we've just looked at there, when do we store data in S3. All really useful concepts to know for the exam. Data integrity and bias. This is a part where a lot of people go wrong. You've cleaned your data, engineered your features, and you think you're ready to train. But there is a silent killer in your data. Bias. Now, bias in machine learning has different meanings. There's algorithmic bias. So this is where your model or architecture or training process leads to unfair outcomes. There's data bias, where the training data is skewed or underrepresented. And then there's measurement bias, which is the way you measure something that is systematically skewed. For the exam, we'll focus on data bias. That's kind of where the certification mostly lands, but it's good to know about the other two as well. So one common measurement is class imbalance, or CI, so class imbalance. Let's take an example. We're building a fraud detection model. Your data has 99.9% non-fraud in it, and 0.1% is fraud. So 0.9% non-fraud, which leaves you 0.1% fraud. If your model just predicts not fraud for everything that is 99.9% accurate, but it's useless, it's absolutely useless for detecting fraud because it's so small as an imbalance in the class data set, it can't actually pick it up. The exam uses specific terminology here. This is class imbalance. So the model predicts not fraud for everything. It's accurate, but it's completely useless. So the problem, the model predicts not fraud for everything. It's 99.9% accurate, but it's completely useless because it cannot detect fraud. Now, this is class imbalance, where you take the majority, you divide it by the minority, and you end up with a ratio of 99 to 1. The other thing that you will need to know for the exam, and this did come up on my certification and comes up in a lot of people's certifications when they sit the exam, is DLP, difference in proportions of labels, and this is used by AWS Clarify to detect unfair bias. I have laid out this slide to give an example of what it is. In this example, I'm looking at loan rates approved in training data. So 40% of women have loans approved, 60% of men have loans approved. The DPL is equal to the 60% minus the 40%, which gives you 20%. This indicates significant bias detected between the labels, between men and women. There are significant differences then where women get approved at 40% and men get approved at 60%. AWS Clarify uses DPL to flag this. A model trained in this data would inherit the 20% approval gap. So if we train this, and it may or may not be a problem, but if we train this, we would definitely see influence and bias because only 40% of men or women get approved their loan versus 60% of men. So there's a 20% difference there. And that's really important. So how do we fix class imbalance? And again, for the certification, you will need to know each one of these. You can oversample. So this is where you duplicate the minority class rows to balance the data set. So you actually then take this red and you basically sample it and duplicate them. And then you end up with a class that's more balanced, shown by this diagram. Preserves all the data, but can cause overfitting because basically you're just taking the minority class and then using it multiple times. You could undersample where you randomly remove the majority of class rows. So you take this green bar and you pick from it in a sampling technique the ones that you want to include, and then it looks more fair like this afterwards. It's fast and it's simple, but it throws away data because you're literally sampling the data that you need or the data that you're randomly sampling to bring the classes down to similar size. So you could up the red class in this one, or over here, we're basically downsizing the green class. There is the ability to do SMOTE, which is where you create synthetic examples of the minority class. So you take the red class and we basically synthesize data that looks like the minority class out of that data. So it creates new and unique samples, but it can induce noise. So there are pros and cons to each one of these techniques. For the exam, you will need to know each one. Here are when you might use some of those techniques. So it is important to know fixing fairness issues for the exam, how we do this. Class imbalance, 99-1, you might use SMOTE. DPL shows demographic issues across the labels, so you might use representative data. Model output is biased, and you've got an algorithmic issue that you need to look at. And then you can see here that we can use AWS tooling for the rest. For the exam, it's important to know that AWS Clarify is the go-to tool for bias detection. So if you see bias detection in the exam, think AWS Clarify. And then when it comes to data privacy, it is important to know about PII data and PHI data and how you can do things. So PII is personally identifiable info. That's things like name, email, date of birth. We never really train on raw PII. We remove it or we mask it, and we'll look at those in a little second. And PHI is health data, so this is medical records and diagnosis. It is highly regulated. If you're watching in the USA, you have HIPAA that applies, and inside the EU, there's health acts that apply as well. You can protect against this by masking with synthetic values and encrypting at rest and in transit. So again, there are different ways to handle this data inside AWS. It's important to know for data residency and compliance. Again, for the certification, you want to mask the PII data and replace with synthetic values that preserve statistical properties. So if you have age, for example, or date of birth, you might want to replace that with age rather than date of birth. If you have names, you might want to change those names into names that aren't actually the people if they're not having any results. In fact, you might even want to take things like their addresses and actually lower them or put them into cities. For example, encrypt at rest, make sure everything's always encrypted. All sensitive data in S3 is encrypted. You want to encrypt in transit as well, so TLS and SSL when moving between AWS services. And then data residency is a hot topic right now, so if you're inside the EU, you may only want that data to be stored inside AWS EU regions like Ireland and Frankfurt. If you're inside the USA, you probably only want that data inside one of the USA regions as well. So it's important to understand data residency, the forms of encryption, and masking PII data for the certification. This is an example of how you could handle PII data. So you can see here that basically we take the name of the customer and we translate that into a hash. So there's no point actually having the customer name in its raw form. We've hashed that. We've took the date of birth and we've converted it into age. We've took the location and we've actually turned it into a region. So we're up at a higher level. And then the spend stays because we actually do need this. So you can see name, email, SSN removed, not required. Date of birth gets derived to age. Name goes to a hashed ID. And this way we're masking the data, removing the columns we don't need, and getting rid of any sensitive data that isn't required for training. So key takeaways out of this section before we jump on to the practical. Class and balance you'll need to know for the certification. DPL tends to come up a lot in the exams. It's important to know that it's from AWS Clarify. It's important to know how you can calculate it using that men and women example. Fixing and balance with SMOTE, where you actually do synthetic data, oversampling and undersampling. We never train on raw PII or pH data. We derive the features, then discard the sensitive data. Data residency rules, GDPR, we must be inside the EU region. We must be encrypted at rest, must be encrypted at transit as well. That's the key takeaways from this section. As I said, spend a little bit more time on DPL. We'll go into it in the example as well. There's a good example during the code that is coming up next. Please take your time around this. It is likely to come up on the exam. So we're going to take now a quick look at data integrity for a demo. So if we go into number 4, and the first thing that we want to look at is the bias detection. So for the exam, you will need to know about SageMaker Clarify. That comes up quite a bit depending on the day and the questions that you get, but it's important to understand how you can use SageMaker Clarify for bias detection. What you'll also see in the exam is talking about around sampling bias and representation of data sets and how you actually get out of that, how you get class and balance. DLP, the difference in proportion of labels, usually comes up in the exams as well. That is quite a good one to spend some time on as well in this code base. Let's take a quick look at the code before we execute it as always. Some of the standard imports that you're probably used to now going through those demos, such as Pandas, the Bodo 3 library, again for accessing AWS. Again, there's the SageMaker being imported as a session. And here this time, you can see that we're importing SageMaker Clarify to use things like a data config, bias config, model config, and model predicted label config. These are all inbuilt methods with SageMaker Clarify that help us with bias detection. For this data set as well, we're going to have to update the things that we usually update. So let's do that now. My region, as always, is US East 1. Please update to the region you're operating in. Next, you need your SageMaker execution rule. By now, you should be pretty familiar on how to get this. But again, in the CloudFormation, in the stacks, into the stack we created, and then grab it from the outputs tab like so. It's the SageMaker execution rule that can be found here. So we just want to copy that and we want to paste that back in here, remove all that data and paste it back in here. And then lastly, we need the bucket name. So again, back out the CloudFormation. The bucket name is sitting there in outputs. We just want to copy it, copy your own bucket name, not my bucket name, back into the notebook, and then we just want to replace the notebook bucket name as well. So like so, and save that in. So that's the updates we need to do to the script to make it run. A couple other things I think that we probably should look at before we go in to it is that we are uploading the churn data set. So if I quickly go back out onto the README, we can have a little look at the churn data set quite quickly. This is a very common data set for customer churn when you're doing data science examples. It's looking in the telecom world of customers that are going to leave or churn through a telecom provider based on the products that they have. Do they have broadband? Do they have landline? Do they have a secondary landline with us or a secondary phone number? Then using the other attributes that you have about that customer, such as their gender, what is the percentage of churn you expect through the data set? And then you can start to come up why it's churning. And then from there, you can offer them new products to stay. So very common data set. That's what we're looking at. And again, you can see all the metrics here if you just want to look on the README. So it's going to upload that, which is really, really important. And then you can see here that we're going to create a data config, which specifies where the data is, the format of the headers, and Clarify expects this in CSV format with a header row. So important, we create a data config for Clarify. Then using the config itself, we're going to look at bias config, which defines the attributes we measure bias for and how that protected attribute may contribute towards bias. So, in this case, we're going to look at gender, but other protected attributes could be race, age, etc. as well. So you can see here in the example, we are going to look at gender and actually the churn of that gender or churn of the data set based on that gender. And is there a bias between male and female churn? Yep. And if we scroll down, step 6, you're running pre-training bias analysis. So this looks at bias in the data before model training, and then tells us the distribution differences between the groups depending on what we're doing. You can see here again, I've put in all the bias metrics that you may want to look at, and it's important then that you feed these into Clarify. So you can see here, we're going to look at class imbalance, we're going to look at DLP, difference in proportions of labelers, we'll look at divergence as well, and different metrics of that divergence. All this is going to get logged for us, so don't worry too much as we go. We can actually explain it once the code is running. So again, let's copy that code. Let's go back out to the notebook that we've been using the entire time here, which has actually cleared itself on me. So what we need to do if you end up in the same situation is make sure the notebook is still in the home directory. If you need a new notebook, out to the home directory and add. Back onto the README, and you need to copy this line to the top of every notebook, and you want to paste it in, and then you want to run it. That's it now set as a directory here so you can access the data. Back into the code because I need to copy it again, and you want to put that into a brand new cell. It looks like this. Okay, and then we want to hit the play button to run the script. So that's it off and running. You can see that we're outputting a cross tab straight away to see that with gender, what does our churn look like? So female versus male, and it's pretty obvious that in this there's going to be an imbalance because I have synthetically created the data to be one. Where you can see 398 of females do not churn versus 99, and you can see that the males are more evenly split. What's happening now is that the data is off into SageMaker Clarify. It is running a SageMaker Clarify job to bring out the imbalance and the bias in the data for what we have inputted in those arguments earlier. So if we go back up, you can see that we're going to look for class imbalance, difference in proportion of labels, divergence, Jensen-Shannon divergence, and then the Smirnov KS as well. So the maximum difference in cumulative label distributions. This will all go into SageMaker Clarify. It will run around and then produce a report that we can read as a PDF in S3. So I'm going to pause the video here, and then we'll pick it up once it's done and look at that report, and we'll dive into the differences in those imbalances that it brings to the forefront for us. Okay, that took about 5 minutes. If you kept it up, it would show you things on screen as it ran through and what it's actually doing through SageMaker Clarify. But the important bit is that actually at the end, it produces a PDF alongside other things that we can look at. So if you go into the bucket and you might need to refresh by hitting this. There'll be a Clarify bias output. And inside there, if we click the whole way down, you get different reports. But let's look at the PDF report. And let's open that PDF report, and I'll open it in my browser, and you can see that we have different things that have been outputted as analysis of this. Let's spend a couple of minutes going through this analysis because it's quite detailed and important that you understand the different metrics for the exam. There's also further information if you generate this report yourself by clicking off the links. I advise you to spend some time more than what I'm going to do right now going through the report to understand SageMaker Clarify and the different options it has when it comes to bias detection. So I'm just going to scroll down to the table to start because it might make more sense. So down the bottom, you get a table that looks like this. And one of the most important things to look at then is this difference in proportion of labels. So it measures the imbalance of possibly observed labels between the facet values. So we're looking at female here, and we're basically looking at the difference of the imbalance between females and males that churn. And here you can see that it's 0.282, or in other words, that's 28% difference in churn rates between males and females. So that is that females churn at approximately 20% of the data set. And if you remember, we knew that from actually the cross tab as well. That was quite visually clear. So let me just show you that really quickly again. So on the cross tab output, which was done here, it's very clear that more of males churn than females churn. So you can see, I know when no, as in no churn. Females are higher than males. So there's definitely some imbalance there when it comes to churn. You can see that visually in the cross tab, but now we have that statistical method of bias as well to look at. I'll just go back to the report quickly where it's at 28%. So 20% the females churn versus 48%. Very clear from the data. That's a massive disparity. If you train a model on this data, it would learn that gender predicts churn, which is a fairness problem. So that's a problem because gender is a protected class. It may or may not be a problem, but it could be a problem. And the important thing is that you're getting this pointed out to you that this problem exists with imbalance. And then the question exists then for you to answer, is this a problem if I train? Because it will say gender predicts churn. And then there's a question amongst, is that important or is that not important? Is that legal? Is that not legal to include that depending on where you are in the world? So that's why these metrics are really, really important. The CI, the class imbalance, which measures the imbalance in the number of inputs with the facet value equal to gender, is at 0.006. So 0.06. So that's nearly zero. Class imbalance measures where we have equal numbers of each data set in the data set. So in this case, we have 497 females. We have 503 males. We are very close in the numbers, and that's represented by that class imbalance. So it's almost perfectly balanced, but even if it has the perfect balance, we can still have bias within the data itself on those labels of gender. And that's where the DLP comes in, the difference in proportion of labels, because although we're balanced between male and females, we do have a difference in the churn between them. And again, there is an imbalance. The question is, when we train the model, we know it's going to find an imbalance between male and female and use that to predict. And the question is that a problem as a protected class for whatever we're looking at right now? Then the CDDL, the conditional demographic disparity in labels, measures the maximum divergence observed in label distribution and facet values. So this is a conditional metric. It's an advanced one. It's asking, does the gender bias persist even when we control for the contract type? And the answer is yes. So we're at 33.4% here. It's even higher than the DLP. So within month-to-month customers and within 1 year contracts and within 2 year contracts, males still churn more than females. So what we're basically saying, when we look at the whole system, month-to-month, year-to-year, different types of contracts, do we still have this bias in our data set that males churn more than females? And the answer is yes. So the churn itself or the imbalance itself isn't in one isolated place. It's throughout the data set. And this is what this number at 33% is saying. And then there's a few other metrics here you can see listed out. I'm not going to go any more depth onto them. It's important to know they exist. And if you want to then look at it more, you can actually just click on them in the report that you've produced and go out to them. And the last thing to know, there is some visuals around how things look and how things are distributed. So it's important that you might want to look at that as well. So there you go. There's the distribution of churn. So you can see no, yes, observe, frequency, things like that. So read through the document and definitely have a look. So the important part to take away from here is that we deliberately in the script introduced an imbalance in churn. It's based on gender. We were able to find that through the DLP, even though our male and female ratio was pretty much equal. Females churned less than males. Now we found the imbalance. We've located it using SageMaker Clarify. The question is that imbalance a problem or not for a protected class that we're going to train the model on? Because the model most certainly will predict on gender the amount of churn. That's questions that you need to answer day to day as a machine learning engineer. It's important to know for the exam and how you can do this using SageMaker Clarify. And this script, if you want to read it in depth alongside this report even further, will start to help you on that journey. And then we want to look at just some data quality detection metrics as well. So if we go into the data quality script that is sitting in that fourth folder again alongside the bias detection one, we can see that the script's going to load a data set. It's going to validate the schema. It's going to look at missing values. It's going to detect duplicate records. It's going to have a range of validation, categorical validation, look at outliers, and generate comprehensive data quality reports. This is quite important as well when it comes to data integrity and bias. You need to ensure the quality of the data. This is a lot more to do with the data's structural being and metadata rather than how the data relates to each other. We're deduping here, we're looking at schemas, we're looking at data types. We want to make sure that the structural of the data quality is sound so it doesn't accidentally introduce any biases that we may see by actually the data being dirty. So dirty data is not what we want here. We want nice, clean data. This script's going to help us out with it. So back on, if you look, we're doing some imports, but we're going to use some Panda profiling basically to look. So again, we're going to load up a data set that is an example here. So we're just going to load it. I'm going to scroll down. We load it into a Panda data set. We have some quality rules here that we're looking at schema validation. So we're checking that the schema matches each other. We're looking at some range validation. So are the ages between 18 and 100, tenure, make sure the charges are sensible, make sure the genders actually hit within, make sure the churn metrics hit within as well. So step one is a schema validation. We're looking for missing columns as well and how we handle them. Looking for extra columns, that's really important as well. Make sure that they don't exist. We then do an analysis to make sure that we have no missing schema values. And then down the bottom, we're looking at range issues as well. I will print this out so we can actually see it running because that is the most important thing here for the purposes of this demo. So back into the notebook as usual. If we just scroll down and then we paste it in and we hit run, we'll start to see this print out. So I have everything printing out for us. We're looking at scheming validation. You can see that everything is as expected. Missing values, we have no nulls. We have one null in tenure, which means the data doesn't exist. So nulls could be important, could be allowed, could not be allowed, but they can skew the outputs of models. So it's important to know that they exist. So you can see here again, we're going through that. We have no duplicate rows. We're looking for range validation. You can see that monthly charges fails actually. So you actually want to then investigate that monthly charge. And as a machine learning engineer at this point, you'll go back into the data, you'll check why it's wrong. You might need to go back to the source system to re-ingest the data. You might want to make a change on the fly depending on what it is. Maybe your ranges are bigger now than they used to be in the pipeline and you need to extend them. But these data quality checks are important so you don't introduce bias in the data set itself. And you see options, remove rows, clip range, flag for review. Categorical validation, gender, we have one invalid value. Invalid values is unknown. We have churn, yes or no. And then here you can see that there are different outlier detection methodologies that we're using in order to find them. So age is no outliers, monthly charger has one as we know, and total charges has one as well using that metric. Then we have a little quality report. So no schema issues, no null values, no duplicate records. Range issues is 1, categorical issues is 1, outlier detection is 3. So 50 out of 100, not great. And then if we scroll down, you can see that we've done other things. So these are other options that you may want to use, like glue data quality exists, which also if you're building a glue pipeline, useful to know. Again, more videos on the channel about this, but I've just created some code that does things that are simple. So you know that it looks like this in the file. And then we actually do some, you might want to do some masking around PII data as well. So again, take some time, read through the file, see what you think, and then move on to the next section. So this is just an example of data quality and what you can do using AWS. Again, in the exam, it might ask you questions like, how do you do this inside deduping? How do you do this inside Glue? How do you do this with SageMaker Clarify, which was the previous example that we went through. Now we're more familiar with the concepts in data ingestion in Domain 1, both from some practical and some theory. Let's look at some exam style questions. Now at the end of Domain 1, we're going to look at some example questions. These come from Noza.ai, which is the sponsor of today's video. Link in the description with discount code if you want to do more practice questions like these. So the first one, I'm going to leave it on screen for a couple of seconds after explaining it, and then we'll move on. So you need to pause this if you want to think longer. So the first question is, you need to ingest 10 gigabits per hour streaming data and make it available for ML training within 5 minutes. Which pipeline should you use? These are your 4 options. Pause the video, think about it, and then unpause when you're ready to see the answer, and I'll move to the next slide. So the answer is Kinesis data streams, Firehose and Parquet on S3. And the reason is Kinesis handles the real-time streaming ingestion. Firehose converts to Parquet and delivers the S3 in near real time. You meet the 5-minute SLA, and the batch approaches A and C can't meet that latency requirement, and D doesn't make any sense to write the EFS or use Lambda in the first instance. Okay, next question. Your analytics team runs frequent queries that only read 3 out of the 50 columns. The dataset is 500 gigabits. Which storage format minimizes cost and query time? I'll pause the video and then I'll move on to the answer. Okay, so Apache Parquet. So you remember we were talking about Apache Parquet before. It's for columnar reads. It needs 3 columns, so you're going to skip over the other 47 and dramatically reduce the input and output cost. So on to the next question. You need to process terabytes of raw data hourly with complex transformations in and out on automated serverless ETL pipeline. Which AWS service is best? Again, read the question. I'll pause the video, read the answers, pick your answer. And the answer is AWS Glue with PySpark jobs. So why? AWS Glue provides serverless scalable PySpark ETL. Again, read this, make sure you understand it. And if you want to do more questions, then noza.ai is where to go. And question number 4. Your training data set has a 99 and 1 class imbalance, fraud detection. Which technique is best to address this before training? Don't forget 99 to 1 imbalance technique. I'll pause the video. And the answer is smote for oversampling the minority class. Why? Because it generates synthetic minority class examples to balance classes, removing majority samples. Again, that's the end for domain 1. If you need more, sponsored by noza.ai, go have a look at their website. Check out the discount code as well, and you'll get more questions to help you learn this information as you go. There's also the Learn More feature on noza.ai, where an AI assistant will actually tell you more about the questions as you go as well. So you've got the clean data, and now comes the fun bit, building the model itself. However, before we start to code, we need to take a step back and ask, what problem am I solving? When it comes to machine learning, there are 3 broad learning paradigms that we need to know for the certification, and 3 in general. You can see that I've put them out of supervised, unsupervised, and reinforcement learning. Supervised learning is where you have labeled data. You have examples and the correct answers. You're predicting a target, classification, predicting categories or regression, predicting continuous variables. Unsupervised learning, you have data with no labels and you're trying to get the algorithm to find patterns for you. Think clustering, dimension reduction, anomaly detection. And reinforcement learning is where an agent learns by taking actions and getting rewards. This is less common in traditional machine learning and more common in kind of robotics or game playing itself. Most of the certification for the machine learning engineer will deal with supervised learning. However, because of the uptake in generative AI, you will get unsupervised learning questions as well around foundational models that we'll cover. And you could get some reinforcement, although less likely in my experience for that to come up. So when it comes to SageMaker, we do have built-in algorithms. So these are algorithms that are provided to us by AWS. The most common one, and the one we'll use in the demo, is the XGBoost. This is the one I see a lot, and it's used for classification and regression. So the XGBoost model is the one that we'll use today mostly in the demos. It's for classification and regression, tabular data. It's the one that comes up quite a lot in the exam, the one I see a lot in practice. But you also need to know the rest of these models so you understand them for the exams. Make sure you take time to learn what they are, such as the linear learner, the deep AR, the K-means for unsupervised learning, blazing text, and so on and so forth. So just spend time looking at this page and taking it in, but the most important one is the XGBoost for the purposes of what we're going to do today in the hands-on part of this section. So on this, I have laid out picking the correct model for the correct scenario. You will get questions like this in the exam. So what I advise you to do is learn the types and then learn the scenarios. So for predicting house prices, it's a regression model, and you probably use an XGBoost or linear. If you wanted to tag spam emails, then it's a classification, and again, XGBoost or linear. Clustered customers into segments. So things that need clustering, you need to think clustering and K-means. Forecast next quarter revenue, well, that's forecasting, so that's going to be deep AR, or you can use Amazon Forecast, which is an inbuilt tooling as well. We'll cover that a little bit more in a second. And then detect objects and warehouse images, object detection, you need an object detection model, or you may be able to use Amazon Recognition, which is a managed service from AWS, and we'll touch on that in a little bit more depth in a second as well. I just wanted to put these two managed services on the slide so you can see them. The important thing for the exam is to read the keywords carefully, and then you can pick. So if it says estimate house prices from the features, then you're thinking regression and you're thinking XGBoost. If it mentions something like detecting objects in a warehouse through cameras, you're thinking object detection. Those are the kind of things that you need to build up as a mental model in your head. Now, I said I would touch upon it briefly, and I'll touch upon it. These are the AWS managed services that you should know going into the exam. If AWS has a managed service for the use case, you should use it and don't build it. That's generally the rule. Don't build it custom. Let AWS do the heavy lifting for you. It is important to read the question to make sure that the AWS managed service does cover everything you need though. We've just talked about AWS Recognition, which does image and video analysis. It's object detection. You've Comprehend that looks at words to look for sentiment, entities, key phrases. That's known as NLP, natural language processing. We've got Textract for document analysis, so we can actually extract from documents and do things with that documents. Forecast for time series may or may not come up. There's Translate for language, Transcribe for speech, there's Poly for speech, and there's Personalize that helps you recommend things in real time. Again, these are just things you need to learn for the exam, so take this slide and learn them. Foundational models have started to appear in the exam as well. So these are generative AI models. You've got two sides. You've got Amazon Bedrock, which is a fully managed foundational access to those models, usually in a serverless capacity. And then we also need to know about SageMaker Jumpstart, where there are pre-trained open source models ready to deploy on SageMaker. So Bedrock, they're already hosted for you. SageMaker, you need to use Jumpstart to deploy them on SageMaker itself. Pretty simple stuff. Your models available today. You've got your Anthropic Claudes, Minstrels, Llamas, Titans, which is an AWS model. There's over 110 foundational models in Bedrock at the time of recording. Take a quick glance at them and then you actually know what they are. While on SageMaker Jumpstart, you might want to go for things like Hugging Face, for example, is available. They can do a lot of the same stuff. They're just different models for different purposes. The main thing is this one's managed for you on Bedrock and you invoke by an API. You don't manage the infrastructure. SageMaker, you need to run the SageMaker endpoints, which means you are managing the infrastructure in some capacity. Then this is the mental model that I use for the exam to pick the hierarchy. So can an AWS AI service do the job? If so, you should use it because it's the cheapest and fastest for the total cost of ownership. So you don't have any infrastructure to manage. So in theory, because you don't need an infrastructure engineer, it should be cheaper to own the entire thing. So if an AWS service can do it, yes. 2, is there a foundational model that you can use? Yes or no? 3, is there a built-in algorithm that you can use on SageMaker? Yes or no? And then if not, you should go to the custom model as a last resort. So if there's something really bespoke that you need done, then it's the last way down this decision tree hierarchy. Again, it's just how I think about it for the exams, so it may help you. So an example of what we're talking about. A company needs to classify product images into 50 categories. They have 10,000 labeled images. What is the most cost-effective way to approach this? There is a built-in SageMaker algorithm for this. You can use SageMaker classification, then use SageMaker built-in image classification algorithm for those images. There's no managed service that can do this. There's no foundational model that can really do this. Then it's cheaper to use it on the algorithm itself. And that's the important part, to say the most cost-effective way, because there are some multimodal foundation models that could give this a go, but they would be more expensive than a traditional classification model on SageMaker. So these are things you just need to know. And sometimes the best way to do it is to do questions like this, such as the ones available in Noza.ai, until you kind of understand when to use SageMaker, when to use Bedrock, when to use a managed service. When we talk about cost versus complexity, it's a bit of a weird kind of trade-off, because the AI managed services may appear more expensive on paper, but when you take in TOC, i.e. the cost to actually maintain a service, that if you were to build it yourself, have engineers look after it, and the speed to market, they're usually the fastest to get going, and the cost then relative to that performance price is low. But if you were just to take the raw price, it may seem slightly higher. So this is the way I think about it for the exams when it comes to it, about managed services, foundational models, built-in algorithms, and custom bring your own models. the way that you can get them to market and the price of doing so to get them that far. Not necessarily just the raw price on paper, but the total development cost to get there is what we're talking about here. The cost of building versus the complexity of getting it out to market. So the key takeaways in this section is that you need to know your 3 paradigms. So the supervised is going to be what the most questions are in the exam, but you can get unsupervised and reinforcement. The XGBoost is go-to for classification and regression. We'll actually be using that algorithm in just a second on the practical. If a managed service exists and it covers the use case, and I mean, that's the important part, you need to read the question, then use it. Obviously, price can be a factor and things that feed into it. So if it is there and it makes sense, always pick it. Bedrock is for managed foundational models. Jumpstart is where you get open source models on SageMaker. And then the exam always tests cost effectiveness. What's the cheapest solution? And whose cheapest solution wins. So these are things you will need to know for the exam again. Now we want to open the model training folder. So number 5, model training. We want to look at the XGBoost built-in training. There's other examples in here. We'll cover the hyper parameter one in a minute, but there are other things in there if you're interested in looking through as well. So this is the script we're going to use to actually do some training of the XGBoost model. It's important to know what we're doing. So you can see this script demonstrates the production grade XGBoost training on SageMaker. It's going to set up a SageMaker session, the IAM role, and the S3 paths. It's going to take a housing data set. This will be synthetically generated in the script. There are placeholders to do it from S3, but again, for the purposes of this video, I wanted to keep it as simple as possible. So we're just going to create data on the fly to train the model. It's going to upload it into S3 where it's required. It's going to get the XGBoost container for the region. It's going to create the estimator and hyperparameters for the instance. It's going to define the train and valuation input channels, and then it's going to execute the job itself and actually build us a model. So that's really important. It's going to build the model in the end. So the first thing we need to do, as always, now we understand what we're doing, is that we need to update these variables as usual. So the bucket name, we can just go out and get again from the CloudFormation stack. So that's the course bucket name. We want to copy and we want to paste that in. Course bucket name here. Our region is US East 1 as always. So US East 1. And then our role ARN is also on the outputs, just here again. And then the role ARN for SageMaker is located right there. So let me then go to back in role ARN and paste. And then we just want to copy this whole file as usual, and we'll take it into the notebook that we've been using the entire time since we logged into the session. So again, that notebook, just don't forget, is sitting in the home root directory, and I've already copied and pasted in the file need on top. So just paste that into the newest cell that looks like this as well. Then let's just have a quick look at the script in a little bit more depth. Now it's pasted in before I run it. You can see here that we're going to load the dummy data set that I spoke about before. We are then going to split it into training and validation, which is this step. We're going to upload it to S3. We're going to create the XGBoost estimator, or we're going to grab that from the region based on its URI. You can see here, pretty important, we're going to have one instance and it's going to be an M5X large. And then on top of that, if I scroll on down a little bit further, these are all the hyperparameters that we're going to put in. We will do hyperparameter tuning after this, but it is important to understand that you have parameters and hyperparameters themselves. So parameters are what's in the data, and hyperparameters is how we affect the training. We're going to use things like the learning rate control. We're going to use things like the depth as well throughout. We'll dive into this in a little bit more depth when the time comes on top of it. And then we're going to output the training set as well. So once you're ready to go, just hit the play button as always at the top. Make sure it's executing. I've put a lot of print statements in, so it will start to print the statements out for us as we go. So you can see it started there. We're initializing the script and we're uploading. We're looking at the hyperparameters that we put in as well. It's really important for the exam to understand what parameters versus hyperparameters are, and we will do a hyperparameters demo next. But just so you're aware, hyperparameters are what we set before training. So these are things like max depth. So in the terms of this XGBoost model, it is actually a decision tree of if-else statements. So if, else, if, else. And max depth is how many of these we can go through. So if we had a max depth of 2, for example, it would go 2. If we had max depth of 3, it could go to 3 levels and 4 levels. There is a trade-off between hyperparameters as you change them around and how the model learns. And what the model learns at the end is its parameters. So parameters are learnt, and hyperparameters are what we change in the model in order to get to those learnt parameters. Different hyperparameters do different things, and the way you kind of manipulate them influence the way that the model learns. And that's important to understand for the exam. It's also important to know in hyperparameter land what ETA stands for. So this is the learning rate. So this is how fast does the model actually learn. Each tree learns from its mistakes of the previous trees. ETA controls step size, i.e. how much of a jump can it make between aggressive learning and low learning. So you can kind of play around with your ETA and your depth levels in order to make the model more aggressive or less aggressive on its learning, but different ways of making it aggressive. And depending on what you do, it affects how the model actually trains. And you can overtrain a model or you can undertrain a model, overfit a model, depending on how you play with these parameters. And at the end of model training, there are ways to use the test data set and the validation data set to understand if the model has been overfitted, for example. And if there is overfitting, then you come back and you adjust your hyperparameters so the model learns in a different way. And by learning in a different way, it will get a different outcome, and therefore you may no longer have that overfitting present inside your model. So this is the training job underway. You can see it will take several minutes. So starting the training job, I'll pause the video here and then we can pick it up once it is finished. Okay, that took about 5 minutes for me today. You can see that it prints out how it's training. And if you scroll right down, blah, 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 you can see training was completed in 3 minutes itself plus the startup time. What's really interesting now to look at is the model artifacts that you can see are located here. So let's jump on the S3 bucket and go take a look at those model artifacts. So on the S3, back out to the top of the bucket that we've been using. It is in my 11:29:45 was my successful run. In here you can see the output, and this is actually going to be the model artifacts if I keep going here as a tar file. Now this is stored to S3, and in the next steps we could take this artifact and then we could actually host it as an endpoint to do inference. So this is the raw model artifact, the output of the training that has been tested and validated against. And we can now take this XGBoost model, host it somewhere and do inference. We'll chat about that more later, but that's actually how you go through training, testing and validation of a model using the XGBoost. Next, we'll take a look at the hyperparameter tuning. So don't forget those hyperparameters like depth, for example, in this is how we set up the model to learn. And as a result, we get parameters. So these hyperparameters, I'm going to show you ways that you can alter them based on the model automatically and using training methodologies. There are so many hyperparameters and so many variance ways. You don't want to guess this. You want to use statistical modeling in order to help guide you the way that you need to tune these hyperparameters to get the best results from your model. This is actual machine learning engineering at its heart when you're playing around with these hyperparameters to get the training, to get the inference, to get the output the way you need it to be in order not to underfit or overfit the model that you're using. Okay, so next we're going to look at hyperparameter tuning. So it'll be in 5 again, then in the hyperparameter model, and I already have it opened here. So we're going to look at SageMaker's ability to automatically tune these models based on the hyperparameters, which is the information we put in before training that helps us fit the model. I'm going to pay particular attention to the learning rate and to the depth for this XGBoost model to show you the examples of how you do this. This is quite in depth. It's going to spin up at least 4 instances of EC2 instances to train on. It's going to go through multiple jobs. This will cost a few dollars. If you don't want to run them, don't feel like you have to, just follow along. I'm going to go through the code now and point out a few things that are interesting, and then we'll run the code and we'll look at the outputs of what that did. So if you just want to follow along, that's totally cool as well. So we'll skip the imports mainly, but you can see this time we're importing the hyperparameter tuner. We do need to do some updates here as usual. So same as always, just grab what your bucket name, region, and ARN are from the CloudFormation script. Alternatively, if you have it open in another tab like I do right now from our last runs, then just feel free to copy them in, because there's no point repeating the same things onto the 5th demo now. Right, what we need to look at is here I'm creating some random data for us. Again, deliberately creating data in the script so we don't have any issues around uploading from S3 or anything like that when you're running these at home. In the real world, you'll be loading this data from your data store, be that a feature store, be that some S3 bucket, be that another database. So we can just skip over that. We split it into training and validation. Cool. Create some CSV files. Cool. Save them down in the S3 so we can actually use them. Cool. Then we create our XGBoost model, also cool. And then we're going to look at the ranges that we want to control with the hyperparameters themselves. So the two I'm going to focus on for the purpose of this is the max depth and the learning rate. You can see I've done others and I have put examples of what they do so you can read through them in your own time. But max depth, if you remember back, is how deep those tree branches go. Do they go 1 level deep, 2 level deep, 3 level deep, 4 level deep, 5 level deep, 6 level deep, depending on what you're doing. Deeper trees can learn more complex patterns, but there's a trade-off because you may overfit. It may see patterns in the data that do not exist. Lower tree numbers, so less depth, i.e. lower numbers, tend to maybe underfit the model. They think they know, but because there's no depth there, they may not actually know and underfit the model. So there's a balance to be struck between underfitting and overfitting. And that's what we're going to do here. We're going to use the hyperparameter training to order to find the correct depth that we need. Then the other one that we're going to focus on today is the learning rate, the ETA. So this is about how aggressive you want to make the learning in each iterative. So each tree of the model learns from its mistakes as you go around learning. So if you go down the decision tree and you get to the end and it doesn't make sense, the model will go, right, that doesn't make sense. I'm going to start again in that decision tree. If you want to be aggressive in the learning, it may say, actually, I'm willing to skip 3 or 4 steps ahead and go to the next place I think makes the most sense. And that's when you have an aggressive learning rate and a higher number. If you have a lower number, then it will say, actually, I'm going to take the next incremental step in this learning journey. Rather than jumping 5, 10, 100 steps ahead, like you might do as a human in your mind, it'll go, I will take the next one. The smaller the steps, usually the better the performance you get. However, it costs more to train the model. And depending on the data set, it may make sense to take bigger steps or smaller steps. So by hyperparameter tuning, we're finding out how aggressive we want to be in that learning based on the output of the data against its validation set. Now, rather than manually then going through all this and going, I want to try this variable, and this variable, we're going to use something called a Bayesian. And I repeat again, we're going to use something called Bayesian optimization, and that's called out just further down here if we scroll down, where we set up a Bayesian optimizer to tune, and it's an intelligent search using past results. So it randomly samples from the ranges, provides a grid of what we've done, and based on the past results comes up with a statistical probability of what the next most likely thing is in the pattern. So for example, let's just say we had a depth of 5 and we were close. Then most likely we would either go to 6 or 4 rather than randomly going to 10. So it starts to work out the most likely patterns based on the previous training to get us closer to fitting what we need to fit a good result of our model. And this is a statistical mathematical probability that we're modeling in order to understand how to change the hyperparameters. And in terms of SageMaker, as you can see in the code, it's going to look after this for us. We actually don't really need to do anything. This is auto parameter tuning. So it's working out based on mathematical probability, the best next parameters to tune. You can see here, I'm going to do a maximum of 20 jobs across all combinations, and I'm going to run 4 jobs in parallel. Now, again, this will cost money. So when I hit run, do not feel like you need to do it. When I hit run, I will show you the steps and the output anyway. So let's get back on. Let's get this executing, and we'll see what the output is. And to do that, what we need to do is copy the code, go back into that notebook as always, our favorite little notebook. We just want to paste that in and we want to run the job. Okay, so that's the jobs off and running in SageMaker. As you can see, the script will compete because I'm not waiting on these jobs in behind. But if you go back out to SageMaker Studio on the homepage and you go to jobs and you go to training, you will see that there's lots of jobs that have been kicked off and some that are running actually here on the XGBoost model. So this is it going through figuring out what hyperparameters are best, and it's going to restore the results in S3 when it figures that out. So once I see no more jobs running here, I know that I have completed the hyperparameter training. Okay, so whilst we can see them running here and going through, you want to go back out to just general SageMaker, go into SageMaker AI, which you can get to by just typing in SageMaker AI, clicking here. Then down the left hand side, you want to go to model training and customization. You want to go to training and tuning jobs, and then you want to go to hyperparameter training jobs. And you can see right now that we've 16 out of 20 completed, and this is testing the outcome of what makes the most sense. So if we click into here, you can see that we're on our last 4 actually going around, and at the end it will tell us what makes the most sense or what the best training job was for this. So far this is the best training job with all the hyperparameters that we put in. It's still in progress. It should finish in the next kind of 5 minutes, and that will be us done. So left hand side, model customization, training and tuning jobs, go into the job itself, have a look at the training jobs that are currently running. We're on our last couple, I think now. 16 complete, 4 in progress, 0 stopped. So once it gets to 20, we'll have an output of what one makes the most sense. Okay, so you can now see that all 20 training jobs were completed under the model training and the hyper trainers. If we go to best training job, then this tells us the one that had the best validation. So these are the best outputs. Now, the one thing I didn't cover at the start, and we'll just look back at it really quickly, validation under the curve. And I'll load up a little diagram so you can see it on screen. But basically what we're looking at is the area under a curve. If it's between 0.5 and 0, and you'll never have 0, but if it's about 0.5, you're randomly guessing, and 1 is perfect. We're not training it because we want to know how the model generalizes on unseen data. So each training job splits some data for training, some for validation. The job change, and then we're looking at the area under the curve. And the closer it is to 1 in these metrics, then this is the better training job. And that's really, really important to know. Moving forward on how we're counting this. And then you can see them back on screen. These are like the ETA that we need to put in. This is the max depth that we want to go as 3. Child weight is 9. And if we input this and use this as our training job, it will get us the best results for the model that we are using. Okay, and then finally in this section, we want to look at the model registry. So the model registry is really important in terms of the examination because it lets you register different versions of the same training model, the same model you have after training. So in the XGBoost example we took, we have a churn model looking at the churning, for example, of our customers and that output. And as we go through versions of the model, we will improve the output, the predictions that we make. So we'll want a V1, we'll want a V2, we'll want a V3, just like we do in software engineering with any applications. The model registry keeps versions of the models and multiple models that we can select in production. So it is a catalog, a registry of the models and the versions that we produce through training in ML engineering. And it's a really important feature when you're building pipelines that you need to version those models. So you can see here, this script is going to create a model package. It's going to register a model with a package, the metadata and approval status. You're going to let you go through the 3 stages of pending, approved, and rejected. So when a model gets added to the registry, you can put it in a pending state. A human can then review it and approve it for usage by your end users or by a production system. And ultimately, you can also reject it. And then you want to just describe and look at the lineage of that as well. Really, really important. So if we scroll down, we've got some code. We need the configuration replaced as usual here. So again, going to be lazy now. We're kind of used to this. Go into another script that I have from before and copy it. Again, if you need to get them from scratch, they're in that CloudFormation template as well. So back into the model registry, and we're just going to replace this because we're lazy. And save. You can see then we're going to initialize the SageMaker session. Nothing new there. We're pretty familiar with it at this point. I'm going to create a model registry group. So it's important to know that the group is just a collection of all versions of a model. So if I create a model that predicts churn analytics, I'll have V1, V2, V3, 3, 4 of that model. That's the group, right? Just really important to know that for the exam. We create the model package and then we register the versions of the model with the metadata belonging to that and the approval status as well. Again, this script is just looking at things that we've created for the purposes of learning. And then it goes on down and we do a whole load of logging. So let's copy the code, and the best thing to do is actually run this code, and we'll just see it updating, and then we'll take a look at the model registry as well. So brand new cell, I'm still in the same Python notebook that's sitting in the root directory, which is down here. If you've lost a notebook, do the plus symbol, bring in the file location from the README, and then run it. Okay, so that's it running. And if we go down, we can see that we are basically taking metrics that we've kind of dummy created. We're adding them to the registry. More importantly, you can see in the registry that it's pending approval. And then we list some of the model packages, and then you can see that actually I described the model package as well. You can see that it passed the validation test, performance exceeds baseline, model approved status has went to approved. So we're taking it through, and then you can see some of the best practices I've printed out as well for you. And then it's really important to see the visual side. So we'll go to the SageMaker console and we'll take a look. So if we go back out into the SageMaker Studio, which is here, and then we go into models, which is on the left hand side, new models. We go to my models. You can see that we have something in our model registry here. So you can actually register manually, but this is the one we have, created it 3 minutes ago. Latest version, if I click onto it, it brings me up the metrics that belong to it. So they're the custom ones that we inputted, and then you get the hyperparameters, you get to look at the artifacts of where they exist on S3 container, and you can have details as well around the metadata, the name, and this time it's just the name of what I created the model, and you can see that it's currently approved to deploy, but I can move it into pending approval, rejected, or whatever I want as well. You can see that there's an audit trail, it's in draft. Evaluate, I haven't done anything with, and train has been completed. Lineage is also at the top, so you can see where we are, how we trained the job, where it got to, and what's going on in terms of the model group. And activity will actually tell you what we've done with the model so far as well. So you can see that we've trained the model on this output, we've done the hyperparameters, and then we've registered it into the model registry. Again, important factors when it comes to the examination. So you've trained your model, and before you deploy it to production, you need to evaluate it. And this means you need to understand where it fails and where the biases are. Now, why accuracy of your model is not enough. This is the fraud situation again from the previous slides, and this is why it's important to know. So if fraud is only 0.1% of all transactions, then the model predicts not fraud for everything. So the accuracy says it's 99.9% and looks great. And you get no percentage of the fraud use cases actually caught, and that's a problem. So imbalanced data, accuracy is misleading. You need to use other things that we're going to cover, like precision, recall, F1, or the area under the curve. These are things that you will need to know for the examination itself. Exam tip: if the data set is imbalanced, accuracy is wrong. The exam expects you to pick F1 score or area under the curve instead. And if you take a look on this next slide, I have laid it out for us on what you need to know. So for the examination, you will need to know accuracy, precision, recall, F1 score, and area under curve. I actually do all of these in the demo code as well, so you'll be able to look then. But this is when you need to use them and what they're doing. I won't go into too much detail right now on this slide, but if we go to the next slide, what's really, really important is to understand this confusion matrix and then how this confusion matrix leads into each one of these four on the right hand side. So you need to know what this all means for the exam. So this is a confusion matrix where you have your actuals on the left hand side, you have your predicted on the right hand side or at the top on the right hand side, and you draw these four boxes on where you have actuals and predicted positive, positive, true positives. So these are things that were positives in the actual labeled data set, and then you predicted them to be positive as well in the testing and validation data set. So they are true positives. If you then have positives and a negative, and you predict them negative, but they're actually positive, then they're false negatives because they're positives. So true positives are positive, positive. False negatives is when we have an actual that's positive, but was predicted negative. So that is a false negative because it's falsely negative. It is positive. Then we have negative, but it was predicted positive. So that's a false positive. So our prediction model said it was positive, but the actual, in reality, it was negative. And then we have on the far right, we have the true negatives where things are negative in the actuals and they're negative in the predictions. So let's go through that again. Let's do it slightly different this time. So if something is positive in the actual and then it's correctly predicted positive, it is true positive. If something is negative in the actuals and it's predicted negative, then it's actually negative, then it's true negative. So true positive is when a positive is actually positive in the predicted, and then negative, when it is correctly predicted negative, is the true negative. They're the easy ones. The next one is when you have a negative and it's incorrectly classified as positive during the prediction process. That is a false positive because it is actually negative. And then the inverse of that is when you have a positive and it's incorrectly predicted to be negative, and then you have a false negative. So positive, 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 negative, negative, positive, and negative, negative. And then from this confusion matrix, we get the 4 definitions of what we've been looking at. So accuracy, will start at the bottom, is easy. It's when you have the true positives plus the true negatives divided by the total or overall correctness of the model. Precision is how much of the predicted positives, how many were correct. So true positives divided by true positives plus false positives. The recall of actually how many positives, how many did we catch? So that's true positives divided by true positives plus false negatives. And the F1 score is looking at a balance between precision and recall. So you're looking at 2 times precision times recall divided by precision and recall. This is actually not as complicated as you think. You just need to learn these definitions and then apply them to the matrix. Unfortunately, it's one of those things you just have to learn, that they are these 4 outcomes, and based on these 4 outcomes, these are what you can actually derive as a metric. Then there's the old, what do you optimize for, precision or recall? Depending on what you're trying to do, and you can see the exam tip here is basically catch all frauds, even if some are illegitimate or fried, is recall. Minimize false alarms. Ingestion is costly. Precision. So optimize for precision. If I predicted positive, I want it to be right. So minimize false positives. And if you're looking for recall, if something is positive, I must catch it. I have to always catch it. Then you're looking to minimize false negatives. So you're trying to catch all the positives you can to optimize from recall. And over here, you're trying to be as accurate as you can to minimize the false positives in total. And then, as I said, in the exam, you're going to be asked these questions. Catch all frauds, even if some are illegitimately flagged. That's recall. Minimize false alarms. Investigation is costly. That's precision. So based on what you're doing, you'll be asked to recall one or the other for the exam. Then it's important to know about these regression metrics as well for the exam. You've got to know about the root square mean error and how it's sensitive to outliers. You've got to know about the absolute mean error and how it's robust to outliers. And you have to know about the R-squared coefficient of determination. 1 is perfect, 000 is not perfect. And then I give you exam tips. Again, you just have to learn what these are, unfortunately. So outliers matter. Robust outliers is this, and then how well do we explain variance is R-squared. So you just need to learn what these are, and then you can apply them to the exam. And that's where practice questions again come in really handy with NOSA.ai. Once you learn that this penalizes large errors, and once you learn that the mean absolute error averages the magnitude of the error, you'll be asked to choose between these 2 in questions, and you'll just get better at picking out when to use one or the other. So what I've done on that note then is actually show you what they look like in terms of when you should use one or the other. And then if you have this mental model in your head for the exam, catch all frauds, even if some are illegitimately flagged, that is recall. So missing fraud is worse than false alarms. You would rather catch a false alarm and be alerted than not have it at all. Minimize false alarms, each one costs 500, that's precision. So you want to be as accurate as possible when calling precision. False positives are expensive to investigate. Balance fraud detection and false alarms. So take the recall and precision and balance it. That's F1 score. And then compare 2 models across all thresholds. That's area under curve. We're going to look at that in just a little second. And then the root mean squared, predicting house prices penalizes big misses. And then this one here is when you actually need to robust to outliers. Again, in the exam for the certification, recall and precision did come up quite a lot for a lot of folks I've talked to. So it's important to know that when you want missing fraud is worse than false alarms, recall is important. False positives are expensive. Then you want precision. F1 score balances the 2. And speaking of the area under the curve, then this is what it looks like. So we will use this again to see in the demo code that I've created, but this dotted line is a 0.5, and this is when the area under the curve is random. So if we had a curve that just went like this, everything's random. One up here is absolutely amazing model. It has absolutely no issues with it whatsoever. It's perfect separation, and this whole diagram would be green. That doesn't happen in the real life. So what you're looking for then is a model that curves up to the left and back across. So this model that I've drawn is actually pretty good. It's got an area under the curve of 0.88. Now, considering 0.5 is random, we're very, very high on this. You need to actually take into account other things as well, the key properties that I've put down there. So usually the best for comparison, higher area under curve, the better the model is, but be caution for heavily imbalanced data sets. So if the data set is imbalanced, you can have bias that actually curves the model up, even though it shouldn't be there. So you're really looking for a data set that's balanced in some manner. You're looking at for higher than that 0.5, and you're looking at curving up to the left in order for the area under the curve to be correct. You can see here, 1's perfect separation, 0.9 is excellent, 7 to 9 is acceptable, 0.5 is random, and anything less is totally unacceptable. So you're really looking for that area up and to the right. Couple of other things that you will need to know for the exam as well. SHAP values comes up a lot, and we'll cover those as well. Clarify, we'll bring them out for you as well, SageMaker Clarify. This shows how much each feature contributed to a specific prediction. So what that means is each feature, whether that be in this case like income, credit score, debt ratio, employment years or age, how that actually influenced a decision. So the feature's importance, how much that feature influenced the outcome of the prediction. Bias detection is important, as we've already covered. Partial dependence shows how changing one feature affects the predictions, and in feature importance ranks the overall feature's impacts on the model. So again, I have called out the SHAP value down the right hand side here, which features drive which prediction, direction of the feature impact, magnitude of contribution, global versus local explanations. And it's really important when it mentions an exam you want to do SHAP values that you think SageMaker Clarify for explainability. So the key takeaways is accuracy is misleading for imbalanced data. You got to use F1, area under the curve, or recall. Precision minimizes false alarms. Recall catches everything positive. Precision versus recall. Area under the curve compares models across all thresholds. The higher to that left, the better. Then down the bottom here, you've got to look at those three other ways of dealing with model explainability when it comes to the averaging, including the R squared. And then lastly, when you think SageMaker Clarify, think the SHAP values. The SHAP values tell you how much those features influence each other and what bias is present as well. But if you want to do SHAP evaluation, so a question might say a machine learning engineer wants to look at the SHAP values, then you have to think SageMaker Clarify. Then we want to take a look in folder 6, model evaluation, and we'll open it up on screen so it looks like this. You can see in this one we're going to look at testing predictions and ground truth labels. We're going to look at classification metrics such as accuracy, precision, recall, F1 and area under curve that we covered in the theory before. We're going to look at other regression metrics. We're also going to look at a confusion matrix as well, and a couple of other things as well, including the SHAP values, which come up quite a lot in the exam. So for the exam, you will be asked questions on accuracy, precision, recall. You will need to know what these are as well, and on top of that, the SHAP comes up quite a bit on top of it. These are the key concepts that we're covering, nothing to know there. In terms of the code, we're doing the usual imports again that you saw elsewhere, but as you can see, we're using scikit-learn metrics to get us some of the scoring. So you can see accuracy score, precision score, recall score, F1, our area under curve, confusion matrix, and so on and so forth is named down here. As with all the scripts, we're going to generate some synthetic data through the script itself. Then using the different scikit-learn methods, we're going to come out with different things in terms of the accuracy, precision, recall, F1 score, and so on and so forth. We do each one of these and it will print it out for us, including the confusion matrix, and then we'll look at what these mean in terms of the results once they have ran. Again, for this script, if we go way back up to the top, what we're going to do is basically copy this out and then run it in that notebook that we've had up the whole time. So before we copy the code, we just need to replace the S3 bucket name. So I'm going to grab it. Oh, I've been signed out. I'm just going to refresh that page. You can grab it from anywhere that we've been using it, but this might be the easiest way just to refresh our memory. So my S3 bucket name is here, and I think it is on one of the 300 lines that we need to change this. But to do this, I'm just going to find S3 and have a little search for it. Maybe bucket. Yeah, so it's got 2 places that it can be found. And you can see right down here on line 300, we've got a couple of places we need to update our stuff for our SageMaker Clarify. So bucket name is one of them. And you need to paste that in like this. Same as always, a role ARN as well, which can be located here. Again, it's exactly the same 3 variables that we've been using throughout the process of this demo. So the ARN can go here. And then the region for me is US East 1. Make sure you update your region to what it needs to be, US East 1. And save. Okay, so then we want to copy all this code out back into the notebook that we've used the entire time. Blank cell, and then we want to run this code. Okay, and once that runs, and it's pretty quick because it is just sample data, I've outputted each of the things that we're looking for. So you can see here that the accuracy is 0.76. You can see here the precision is 0.77. The recall is 0.75. And just to remind you, this is synthetic data, so I've deliberately introduced noise so we can see the different results compared to the theory that we learned earlier. You can see then, I'll just scroll on down, the area under the curve here is 0.84. These are some of the regression metrics here as well. And then before we dive into this in a little bit more depth, we scroll down the confusion matrix, which is really, really important to know. So this gives you the predictions of actual negatives, actual positives, false negatives in a matrix that lets you understand what's going on. So I've printed that out to screen for you as well with what's going on. So you can see true negatives, correctly predicted negatives, false positives, incorrectly predicted positives. So these are type 1 error, i.e. they're actually negative. False negatives, which are actually positive. Incorrectly predicted negatives, which is a type 2 error. And then your true positives, which are the ones that are actually correctly predicted. And then this gives you some derivative matrix that you need to know. The area under the curve that we looked at earlier in the theory, this is what it looks like plotted. So that red dotted line is just a random classifier at 0.5. So that's what bad looks like. 1 would be a perfect model. We don't really get those. And what we can see on screen here then is this curve, and it's the area under the curve that's important to see if this is a good model or not. This is a reasonably good model, actually. It predicts quite well. You can see by that curve up and round. So you're really looking for that high curve as much as possible towards that 1. And the closer it is to 1 up here, then the better it is at the predictions. And this random red line that I've put on is literally a random classifier to show you what bad looks like in terms of predictions. Again, I've printed out all the information that you need to look through. Here's your SHAP configuration, your HAP. So this comes up quite a lot in the exam as well. It's important to know how your features relate to each other so you can see what influence they have on the predictions themselves. And I've actually printed out the interpretation for you. So monthly charges is the strongest predictor of churn at 30%. So that's the 0.3. So that's 30%. Age is the second most at 0.25, and tenure, i.e. as long as they are with the company, is 20%. So these are the influences that the individual features have on the prediction. So the amount we charge a customer, their age, and the length they've been with the contract affect the prediction the most. That's what the SHAP, the SHAP values, are all about. That usually comes up in the exam as well, so it's good to know. And then I kind of skipped through it at the start, but this is the evaluation summary. So you can see overall correctness, confidence in positive predictions, the recall, the F1 score, and then the area under the curve, ranking the quality of our predictions. And the model shows acceptable performance in this output. It's probably worth knowing as well that because we ran it through Clarify, we get some things that we could actually do to make it better. So these are the recommendations from Clarify to say that we can make it better. Important to understand these classification metrics. You will be asked about accuracy, precision, recall, the F1 score, and the area under the curve. It's also very important to understand and be able to read a confusion matrix like this, what false negatives and what false positives are, type 1 and type 2 errors. It's important to be able to understand what this graph means. So the dotted line is random. This is our actual prediction. We did pretty well. And the other thing that comes up a bit in the exam is the explainability through Clarify. So it's important to know which features drive the predictions and be able to read it as in this. So you know the higher the value, the more it contributes towards those features and the derivatives of those features as well. It's about what features matter to the output. Now we're a little bit more familiar with the concepts in Domain 2. Let's look at some exam style questions. My advice is to pause the video as the slides arrive and then unpause when you've read them. I'm pretty quick on the slide moving just to keep the video time down. Domain 2, sponsored by Noza.ai. Again, if you want more AWS exam style questions to revise from, including an AI learning assistant, then go to Noza.ai, link in the description, and also a discount code for people as well. So 4 questions ahead. I'll do the same again. We'll read the first question, we'll pause it, and then we'll move on to the next answer of that question. So make sure you pause the video. A retail company wants to group customers into segments based on purchasing behavior, but has no predefined labels. Which ML problem type does this apply to? Pause the video, read the answers. That's right, clustering unsupervised because there are no labels. Again, pause the video, look at the explanation, and then we'll move on to the next question. In a medical screening test, missing a positive case could be life-threatening. Which metrics should you optimize for? I'll pause the video. You think about the answers. That's right. Recall. Catch all the positive cases. If you remember back to that confusion matrix, we go through these. Next question. You're comparing 2 fraud detection models and need a single metric that works across all classification thresholds. Which metric should you use? Again, pause the video. That's right, area under curve. Why? Because it measures discrimination ability across all thresholds. And the last one, you need to predict house prices and you want to penalize large prediction errors with more heavily than the small ones. Which metric should you use? Again, pause the video. And the answer is root mean square error. Squares are error before averaging, so large errors are not penalized disproportionately, so that's what you need to remember, and then it explains more. Again, Noza.ai has more questions to help you prepare for your AWS exam. Link in the description alongside a discount code. So your model's trained, tuned, evaluated, and registered. Now the big question comes, how do we get it into production? How will your application consume predictions from this model? Key factors to consider when we're talking about different deployment types and end types that we can put these models onto. We need to think about latency, milliseconds, seconds, minutes, traffic. Is it always on? Does it burst? Does it actually have no traffic? Maybe during the night when there's no business volume. Volume, is it 1 request at a time? Is it millions requests at a time? And then cost, how much are we willing to pay per time we need to do inference on this model? And with that in mind, then there's kind of 3-ish things that you need to know for the exam and a little bit more. The first one is the real-time endpoints, and we'll cover this when we actually deploy a real-time endpoint in the demo code. It'll give you less than 100 milliseconds of latency. Typically, you deploy a model to SageMaker endpoint on a dedicated instance. So we give it a dedicated compute instance in SageMaker and we deploy an input. The application sends a request, the model predicts, and it returns a result. Instances are always running, so we pay even when we have 0 traffic. And then for the exam, these are the advantages and the trade-offs. So lowest latency, always available, supports auto-scaling, costs money even when idle because we're paying for always on compute, must manage the instance types and scaling. So we as the user have to manage the instance types and scaling, and it's higher cost for intermediate traffic. Exam tip, low latency predictions will with constant traffic, think real-time endpoints. Then we have serverless endpoints, which are similar to Lambda functions that I'm sure you're quite familiar with when we get to this point of AWS in this exam. So you're paying per invocation. You do need to be aware that there is a cold start. So if you haven't used the endpoint in a while, AWS takes a little second to spin it back up. If you think about it in we just covered real-time versus serverless. When it comes to infrastructure, the real-time example we just covered has a dedicated instance. And then when it's serverless, AWS manages the instance. Latency is milliseconds. It is seconds on a cold start for the first time you use it. Then it will drop to milliseconds. Cost, you pay for all the uptime on real time. We're only paying per invocation on serverless. And it's best for constant high traffic. This is better for intermediate or unpredictable traffic. And when it comes to the exam, look for things that are like unpredictable traffic patterns, sometimes zeros requests. Think serverless endpoints. And then the next one you need to know about is batch transforms. So this is where you want to do millions of records in one go, and you don't actually need to provision an endpoint. You put all your data into S3, as you can see here. You use batch transform, and then it gives you the output of that data. It's much cheaper, and works for bulk scoring, so there's no idle time. Minutes to hours is what you need on the data volume, so this is for long running use cases. Good for like overnight scoring, periodic predictions, and data enrichment. You do not need to provision an endpoint for this. You just use the model artifacts that you've created, and then it's all part of that SageMaker batch job. So if you see in the exam something like score 1 million transactions overnight, think batch transform. And then the last one, which is similar to batch transform but slightly different, is asynchronous inference. So you have a request that comes in, it hits a queue, a model processes it, and then the output goes to S3 asynchronously. So it's async. So long running predictions, think about 10 minutes, 15-minute predictions, large payloads that exceed real-time endpoint limits. So we're not doing batch and we're not doing real-time. We're doing something in the middle where it's so big it'll take over 10 minutes to run. Good for bursty traffic, so the queue absorbs spikes without over provisioning. Can scale to 0, so when it's not running, you don't pay for it. So when you think long running predictions with large payloads, think asynchronous inference. And then the other thing that you might need to know for this as well when it comes to the deployment and endpoints is feature store and Lambda. This is an ultra low way of getting inference via pre-computed predictions. So you can offline run model with batch predictions, store pre-computed results in SageMaker feature store, so that's your online store. Then use Lambda functions to look up the pre-computed predictions, so there's no model invocation, and return in sub-second, millisecond latency. So this is where you've looked at the predictions ahead of time, stored them in feature store, and then you use a Lambda to retrieve them. So you're not really doing predictions, you're just retrieving pre-predicted results. So this is when there's a finite set of inputs and you need sub-second and millisecond latency. It is not suitable when there's an infinite input space. Model needs fresh data, continuous learning required. So this is where you make predictions up front. You store those predictions and then you just retrieve them when you need them. And again, doesn't suit every use case, but it can come up in the exam, so it's important to know. And then this is the giant comparison of them all. So if you're going to go for the exam, I advise you to learn this slide. So real time, thinking of milliseconds. Serverless, think of seconds because of the cold start, but don't forget it will drop the milliseconds after the cold start, and it's best for intermediate and unpredicted workloads, while low latency and constant traffic is real time. Batch is minutes and hours per job. So batch is minutes per hours per job, bulk scoring, overnight processing. Async is minutes, so you pay for the compute, long running, large payload predictions. And then that feature store lookup with the Lambda, where you're looking pre-computed lookups, is only good when you actually have a finite amount of input space or a finite amount of options in your prediction. So when it comes to the exam tip, you need to read this scenario. You need to know what this slide thinks and looks like. Then you predict the traffic and the volume required, and then match the deployment pattern. These are examples, and we will look at more later using Noza.ai as usual. But if it says score 1 million transactions overnight, you got to think batch. Real-time predictions with 100 milliseconds latency on the SLA, the service level agreement, you got to think real-time. 0 to thousands of requests and unpredictable because it's all over the place, your traffic pattern, you gotta think serverless. Model takes 10 minutes per prediction, you gotta think async. And then sub-millisecond lookup on finite set of customers, then it's a feature store in Lambda, where you've stored the inference outputs already and you're just retrieving them. Again, focus on the keywords: latency, traffic pattern, payload size, cost constraints. I think latency plays into it a lot, so that's the one I usually start with. Then I look at traffic pattern and payload size to start working things out from there. In my experience, the feature store and Lambda way of doing things, where you're looking up those pre-computed predictions already, is the least likely that I have saw across the exams, and others talking to them. Doesn't mean it won't turn up, but it's the one I see least. And then the other ones are the ones that I see more commonly on the exam appear. So your key takeaways: real-time endpoints deliver millisecond latency. Serverless endpoints remove infrastructure management, so you only pay for invocations. Risk of a cold start, where it'll take seconds to spin up the first time if you haven't used the endpoint in a while, then it will drop the milliseconds of latency. Batch transform is the cheapest for scoring millions of records offline. Async inference handles long running predictions with automatic queuing. Feature store in Lambda delivers sub-second, millisecond lookups for pre-computed predictions. So you already computed the prediction, you've stored it in feature store, and then you're just looking it up. And then the exam strategy, top tip, look for latency, traffic pattern, and volume, and then match that to one of these 5. Okay, so next we're going to look at actually the deployment of endpoints. This is a bit more a bit more interesting, I would say. So let's do the real-time endpoint deployment file. It looks like this. For this demo, we're going to use the churn analytics, and we're going to deploy a real-time endpoint that can go in and get those churn analytics predictions for us using the model artifacts that we stored in the model registry. Okay, and on the script, there's a few things we need to fill in. I'm going to show you how to get the additional information that we haven't got before, and then we also need to get this copy and paste it into the notebook as normal. Let's start with the easy one. So the easy one is the region. So it's just US East 1 or whatever region you're working in. Your SageMaker ARN rule, well, I've got this open still from earlier, so it is just the same execution rule we've been using throughout. So those two are pretty easy. Okay, and then once the model URI, so the easiest way to get this is to go back out into our SageMaker home, go to models, my model, go to view latest version, then go to this at the top. It's the housing model itself. It's probably the easiest one to go to. Go into version 1. Perfect. Go down to artifacts. And then here you can see that this is the location on S3 of what we need as the URI. So just copy that. Then take that out and go and paste it. Perfect. Just make sure that that's all in correctly. Save that. And then to get the container image URI, we need to run a piece of code. So if we go out into the README, and you'll see important code to get model URIs, you just want to copy that code, paste it in, and then you'll want to run that code. And this little thing that it prints out here is what we need into our code. So our container URI. We can use the rest as default. That's perfectly fine. And then we want to do what we've always done is then copy and paste this in as a new notebook. So we're going to go in and we're going to actually then run this notebook, and it's going to create a model from the model artifacts that we've actually created already. So those tar files that we've put into S3. So we're going to use those tar files from our already outputted model that's in our model registry, create a model, deploy that onto a real-time endpoint, an EC2 instance, and then do some inference from it as well. This will take a few minutes to spin up, but you can watch the printout as we go. Run. It'll then start to deploy the endpoint. So I advise you to watch this printout as we go. It'll take maybe 7-8 minutes, something like that, to deploy, but just watch it print. So we're actually taking the model from the model registry, stored as a tar file as the artifacts in our S3, deploying this to the real-time EC2 endpoint that we described in the theory. So that's what's going on. Read through the code, understand what's going. We're then going to invoke the model and do some housing analytics prediction churn. So in this example with the model, we're using the housing data churn model that we had in our model registry. You can actually also check this on the SageMaker console as you go, just so you know. So down the left hand side, you go deployments, you go endpoints, and you'll see that it's currently creating. So it's still modifying here. It's interesting to hit a refresh and just keep an eye on that as it goes as well. Again, it can take several minutes. So I'm 10 minutes into this deployment and it's still not ready. Okay, so that's in service, and if we go back on the cloud onto the notebook, you can see the endpoint was created, and you can see that we did an invocation of our payload, and then we got a prediction of what the result would be of that payload. If we just go up a little bit here, you can see that we create a model, we configure the endpoint, we deploy the endpoint, and then we actually here on point 5 put in some information in order to carry out the inference and get a result back. That's really, really important. Now, also, just while we're looking at this code, it's also important to point out that when we enter at the top, blah, 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 back to the top, this image URL, it's creating a container, and in that container, we are deploying our model. And then on that last step, we're using the model to hit the inference, and this container is always running. So on this inference, the container is always running, whether we're using it or not. And that's why we're going to take a look at serverless inference next, where we only have the compute active when we do for the payload itself. So this is pretty quick up and down, but because it's totally in service all the time, then we're constantly paying for this. So let's look at the next one and move on. Okay, so next we're going to look at the serverless endpoint. So in this case, this is where we're deploying without a container this time. Okay, so for serverless, there's a few things we need to update in the code. The first one is then US East 1 region. The ARN's easy. We can just grab it from over on the CloudFormation outputs or any of the other notebooks that we have used it in so far. We just need to paste this down. We need the URI code. So the easiest place to get this from is the real-time one that we just did. And I'm just going to copy and paste that in from the real-time S3 URL. Then you need to get the container image. Again, well, that's pretty easy because we already know where that is. It's on this code we got up before. So we'll just copy and paste the image in the same way we did from the real-time. Perfect. Then these are just the names of what we're going to give it. So what we'll do is we'll just quickly look at this code. So we're going to create the SageMaker model itself from our artifacts. We're going to configure the serverless endpoint that we're using. Max concurrency is important to know for the exam. This is the number of concurrent inference requests we can handle. The memory as well is per request. So don't forget, before we were running this on a compute that's always running, serverless inference, we're only running it when we need it. So that's really important to know. This is how we deploy the serverless endpoint here. And then this is us looking at cold start latency. So just so you're aware, you can't have cold start when you're serverless. If we haven't ran inference for a while, everything we've provisioned gets torn down. And when we first go for a call, AWS spins that container back up for us. And then we do inference. And that delay between spinning the container up and actually carrying out the inference is known as a cold start. If we're using real time like we were before, there's no danger of a cold start because our compute is always on. So serverless, only when you need it are you hitting it, while if you're using the steady state real time, it's the compute itself is always on. Always on, that's the difference. Okay, and then for this, we want to just copy the code as always, and we want to go back into our Python notebook, take a new tab or a new cell in the notebook, and then hit run at the top. This will then start to run, and then we'll start to see the output of that. And again, we can just watch this come through on the serverless demo, and then eventually it will go to in service, and then we do have a little bit of a code to show you kind of like what's going on in terms of the inference, and then that cold versus warm start if we're interested as well. And then we actually do a bit of description as well on top of it. But for now, it'll take a few minutes to come up, and then eventually it will come into service. And we'll pause the video here and pick it up when we're ready. Just a little reminder that you can go on to deployments, endpoints, then hit refresh, and you can see your endpoint coming into existence here. So once it goes in service, we're good to make that inference call. Okay, perfect. So you can see that our serverless endpoint has now came in service. If we quickly go back, I have printed out everything that we need. So you can see came in service. Then we actually see what our variant is doing. Our max concurrency is 5. So that's the amount of concurrent requests for inference we can make to this serverless endpoint. Again, it's serverless. We're not provisioning the compute. I then actually did a call to it. So a first call and then a back-to-back call. So you can see that the first call is slower. So that's the part of that cold start we talked about how it takes longer the first time you call it in a while. And then I've done some warm predictions afterwards, and you can see the difference that the average cold start was 145 and the average warm is 81, 1.8. That difference, that will differ depending on how long it's been cold for, how long the last time you called it for, how long AWS decided to keep your container warm. It does get smarter as it goes, but again, that's serverless for you. We're not provisioning compute. We're not looking after the compute. This is you call it on demand and you use it on demand. Latency is longer than real time. So this is all about latency when it comes to the exam. If you need sub 100 millisecond latency, then you have to use real-time compute. If you're happy with hundreds of milliseconds, 500 milliseconds of latency, then you can use serverless. There's also something about managed infrastructure versus non-managed infrastructure. So this is managed infrastructure by AWS. Another top tip for the exam, if it asks you, we need to do predictions in near real time with managed infrastructure to lessen the operational burden, then you would pick serverless as well. Next, we need to look at batch transforms. So again, back in and load up the batch transform script, which sits here. We need to replace these variables. If you still have the serverless demo opened, the easiest thing to do is actually go to the serverless demo, and you can see that you can copy and paste across the region, the role, and the model name. So they're quite easy to get. So the region and the role are the first two. So I'm just going to copy them across because there's no point going back in to find them if we already have them. The model name is here on your serverless script, and you just want to paste that in here. Then the bucket name, we will have to go to the CloudFormation output and we can just grab it from there. So that's the same as we've been doing the entire time. Nothing new here. So just paste in your bucket name. All right, save this. And as usual, just copy this in, put it into this, and then run it in a new tab and hit run. Now, while this is printing, let's take a little look at what it's doing. Time to get to the bottom, it might be done. So again, I'm uploading some data to S3. So when it comes to batch, as I explained in the theory, batch is where you want things to take maybe like 15 minutes and you don't mind about the scoring coming back in minutes. This is particularly useful if you're operating a mortgage company and you want to rescore 5 million mortgages. It's particularly useful if you're going through thousands of photos and you want to do something with those photos in terms of recognition, but it's a bulk operation. You upload the data to S3, you wait, and then it comes back. This is a cheaper method of inference, but you've got the longer period of latency when it comes to those results. And during the exam, you will be asked, like, I have mortgage applications that need scored on a Sunday night and I have 1 million of them. I'm happy to wait 15 minutes on the inference score coming back. Then in that chance, or in that case, you will choose the batch inference over the other inferences. So longer latency for the inference, you start to think batch. Also, upload to S3 is important. If you can't upload to S3, then you can't use batch. These are all the types of wording that the questions are going to come on the exam for the ML engineer. So important to know. Now, if I scroll down, probably this might be done by now because I was speaking for very long. And yep, we're good. So I uploaded the data to S3 as I explained. We created the batch transform job using the model that we already have in the registry that we've used for our 2 previous examples. It goes in progress. It completed in 92 seconds. And then it puts the output here to batch transform. Now I have went and got that and predicted it as well. So these are the predictions on the churn. So we got some data that we uploaded and created to S3. We use that market churn model that we've been using this entire time for the real-time examples. So we've used the market churn model. We've done it in a batch format where it's took the data from S3 and behind the scenes, put it through the model using the model artifacts that we specified in the S3 location. It's predicted back 10 rows of prediction for us. And you can see here, I've actually put things so you know for the exam time. So real-time, low latency, persistent traffic. Intermediate traffic, cost optimization for serverless. Batch, large data sets, no real time. Async, large payloads, long processing time. Key for the exams. Now again, just to rephrase what you did in batch here, we created some script up the top that gets some dummy data, which is here, in order to be predictive. So you can see 5 features: square feet, bedrooms, bathrooms, year, built-in garage. We go through this. We provide this to a model that we've already created in S3. So it's the same model we've been using the entire time. I repeat, it's the same model we've been using the entire time. It's that prediction real-time housing data that we had. We upload the data. I get it to do some inference for us in the code, and then we print out those results in a batch format. So again, this is batch based on the housing data, exactly the same as the other 3 endpoints that we're using. Okay, so we can train and build a single model. But in production, you're usually not going to do that once and forget about it. You're going to need to retrain periodically. You're going to monitor performance. You're going to handle new data, and you're going to manage multiple models. This is where orchestration comes in. So production ML isn't a one-time event. It's a continuous process. So without orchestration, everything is a manual process. We don't have any monitoring and everything's just a bit scattered and all over the place. And with orchestration, we can schedule training. We can do built-in monitoring. We can look at managed deployments. We have a pipeline as code if we want, a multi-model management at scale. So production needs, you'll need to retrain periodically, monitor performance, handle new data, and manage multiple models. And that's why orchestration is so important. So for the exam, there is an emphasis on SageMaker Pipeline. SageMaker Pipelines is a serverless orchestration service specifically for ML workflows inside SageMaker. You define your pipeline as code, which is Python, and then SageMaker handles the scheduling, monitoring, and logging for you. So it's important to know this for the exam, that for the key features, pipeline is code, it's serverless, no infrastructure. Built-in steps, so you have process, training, tuning, transform, and so on. Model registry comes into play, which we saw in the demos and will continue to use in the demos. And then we have lineage checking as well. We have a full audit trail, which I'll show you what it looks like of how the data happened. So when it talks about a pure machine learning workflow orchestration within SageMaker, you need to think SageMaker pipelines for the exam. Pipeline steps, important to know, will come up in the exam. It may come up in the exam things like, is there a conditional step, i.e. if the accuracy is higher than 0.9 or 90%, then deploy. If it's lower than 0.9%, call back into the registry and say not approved. So it is important to know these steps. You just have to learn them and what they are, and we'll see some of them on the AWS console. Outside of SageMaker pipelines, it is important to know step functions. This is a more general purpose state machine orchestration service. You can use to orchestrate SageMaker jobs, Lambda processing functions, SNN notifications, those sorts of things. So it is a state machine that lets you evaluate and pass jobs and Lambda functions and tie everything together. It's cross-service, as I already mentioned. So it's cross-service. When you see that in the exam, it's important to know, and it can handle errors as well. So there are the two main ones that come up on the exam. So I did put together this slide that shows you pipelines versus step functions. It's pipelines specifically for ML, more general purpose with step functions. Definition is Python, definition is JSON. SageMaker only integrates with more AWS services, and so on and so forth. So you will need to know this for the exam. And an exam tip, pure ML, think pipelines, cross-service or non-ML steps. Start to think step functions and heading in that direction. Other things you need to know for the exam, AWS managed workflows for Apache Airflow. This is a very common ETL code type thing for doing orchestration. You'll find lots of examples on my channel of this, but this is when you define DAGs in Python. You'll also need to know about Event Bridge for event-driven architectures, and you may get asked questions on Jenkins and GitLab and things like that. Doesn't come up as much in the exam as it used to, or as much in the certification. Workflows are good to know, and Event Bridge is good to know as well. This is what the pipelines as code looks like, and we will run through it inside our example. But so you know, with those steps, you put in a conditional step here in line 9, where it's saying basically if the accuracy is greater than 90%, then go to deploy. So if register, if deploy. So this is what it looks like as code to build SageMaker pipelines. And then for the exam, you need to be able to map the scenario to the tool. So that's really important. Automate trailing, evaluation, and model registration, SageMaker pipelines. Orchestrate SageMaker Lambda and SNS notifications, step function because you're multi-service. Trigger retraining when new data lands in S3, Event Bridge. Training weekly data with complex DAG dependencies, then you're going to need to use MAA, managed workflows for Apache. Deploy if only model accuracy exceeds a threshold, then you're in SageMaker pipelines. Run SageMaker job, then update DynamoDB, then send email. Multi-steps, cross-service, step function. Pure ML, pipelines, multi-service, step functions, event-driven trigger, Event Bridge. This is high-level exam tips. It's not exactly this way. The more questions you do, the more exam prep you do, the easier it is to spot these things. But this is a high-level mapping and a mental model you should have in your head. So key takeaways for this section before we jump into the demo. Production ML needs to be orchestrated. SageMaker pipelines are serverless. Python SDK, built for machine learning workflows. Conditional step within SageMaker pipelines enables quality gates, deploy only if metrics. This is one of the things you do need to know for the exam. Step functions, general purpose, go over the 200 services inside AWS, have state machine orchestration. Managed workflows for Apache Kafka and Event Bridge are useful, but less exam focused when it comes to it, less cert focused. And then decision rule, pure ML, think pipelines, cross service, think step functions, and that's a good mental model to start with. Okay, next we're going to look at SageMaker pipelines. So back out and we want to go into CI/CD pipelines, and then we're going to look at SageMaker pipelines, which sits here in the code. You can see here we're going to input some variables. We're going to do some processing around data transformation in the scikit-learn. We'll do some training, evaluation, conditional, and then register the model in the registry. So this is very much those ETL pipelines that we've covered in the theory section before we've jumped in here. This is just how you create it in code. We're going to use the same data we've used before. We're going to use the same models we've used before. This is just the code. So I'll step through the code to show you how you set it up. I've printed out everything as usual as we go so you can see the steps. Take as much time as you need to read this. I am just going to point out the important things that you need to know for the exam. You could spend hours reading these files alone. If you have the time, really worth it. If you don't have the time, at least read the printed statements. Running the code is not what we're after here. It's reading those printed statements so we get a feel for the actual practical of what we've learned in theory. So back over here, we can see again, it's the standard stuff, what we need to input: region, role, bucket name. So region, as always, for me is US East 1. Again, if you're using a different one, type it in, but it is a lot easier if you use the same one as me. Role ARN is down here in the CloudFormation script. Again, you should be well versed in this by now and putting it in. And then after that, we do need the bucket name that you've been using this entire time. So back into the CloudFormation script, and the bucket name is sitting around here for me. So I'm just going to copy that, and then I just want to paste that in the bucket name that sits right here. I'm going to go up and make sure that's all in one line. We just want to save that as well. We'll have a quick look at it. So we're just going to put in the pipeline parameters. So these are the parameters that we're using. So processing instance we're going to use. This is what's actually doing the data processing for us. What our training configuration looks like, we're going to use the ML-M5 2x large instance. We're going to go through one training instance count, or we only need one training instance count. These are all the max depth that we've talked about previously, the learning rate as well. Max depth, don't forget how many tree nodes we can go down. Learning rates, how fast we learn. It'll default to approve when we actually go through the model itself, and we have a quality gate as well that it has to be over 0.5 in order to go through. When we scroll on down here, you can see then we've got the processing script laid out. I'm not going to bore that with you, but you can read through it in your own time. The model training script that we already looked at when we were doing model training before. Evaluation, what's the model quality? That's the script for it there. Again, I'm going to print this all out for us. Conditional script, so here's the conditions that actually makes it true or false for the quality of the code. And then this is the script that registers it in the register model puts it in the model registry again. And then this is the full definition here of the pipeline. I'm going to execute this because it's a lot easier to see it when it starts to print out than it is in code. Again, if you have the time, feel free to read through the code file. If you don't have the time, then make sure at least you read the printouts of these statements as you follow along. I have managed to copy the complete wrong thing in. So again, you need to go back in, Control A, Control C, and then I'm just going to paste it into the next available cell in the notebook that we've been using this entire time. And when ready, hit play. Okay, so it's off and running here. Now, we may actually fail the first step because I don't have the processing script in S3. What I really want to show you is what the DAG looks like in SageMaker itself, because that's the most important thing that you can see. So if we go back out to SageMaker and we go pipelines, and we can see that we've created that pipeline now starting here. If we click into the pipeline, we have a couple of failures, but that's because the script doesn't exist. That's okay. No problems, really. This is what we actually want to see here. So you can see that there's different steps into the training job. Again, I don't have the pre-processing script. This is made up. But what you want to see is this DAG for the pipelines itself. So this DAG shows you how we're going to pre-process, do training, go to an evaluation stop, register the model, and then get the quality conditions as well. So this is really the output of our script and what we wanted to see. Again, the actual running of the job, not that important. It's this output of the DAG that you need to know for the SageMaker pipelines. And you will need to know for the exam as well how the DAG looks, why we use pipelines over something like glue on top of that. And then lastly, quickly, I'm not going to run the code for this section, but just to make you aware, there are things in here for blue-green deployment and event bridge triggering as well for the pipeline. This is just code to show you how it's done. Again, there's no need to run this code. Just understand that you can call SageMaker pipelines in an event-driven manner for the exam. Now we're a bit more familiar with the concepts in Domain 3. Let's jump on and look at some exam-style questions, again brought to us by Noza.ai. My advice again is to pause the video as the question appears and then unpause it when you know the answer or want to check the answer. I'm pretty quick through these questions just to keep the video time down. Let's check some of them out. Domain 3 questions, again we'll do 4 questions. Again, we're being sponsored by Noza.ai. This is exam-style questions and learning with an AI-powered learning assistant that you can ask more of the questions and more about the answers answers to as you go along. Link in the description as the discount code. And first question, you need to score 1 million customer records overnight for a marketing campaign. Predictions aren't needed in real time. Which deployment pattern fits? I'll pause the video, you pause the video, and then we'll move on to the answer. That's right, batch transform, because it's designed for large scale offline scoring. It spins up instances, processes when the data set and writes the S3. Next question. Your API gets zero traffic for hours, then it suddenly bursts into thousands of requests. You want to minimize costs during idle periods. Which pattern? Pause the video. That's right, serverless inference endpoint. Why serverless? Because it can scale to zero. We have no idle cost, and then it can auto scale up on demand. Don't forget about those cold starts though. Can take up to 1 second or a few seconds from a cold start. But once you have inference again, it will be milliseconds in latency. Question number 3. You want to automate data processing, training, evaluation, and register the model if the accuracy is greater than 90%. Which tool is best? Again, pause the video. Think about the answers. That's right, SageMaker Pipelines, because it's purpose-built for ML workflows. And the last question, you need to orchestrate a workflow that runs on SageMaker training job, then updates DynamoDB, then sends an SNS notification. Which tool? Pause the video. That's right, step functions, because we're multi-service. That's how you have to think. And again, video sponsored by this section, and the video sponsored by Noza.ai. So more exam style questions like this with detailed explanations and an AI learning powered assistant, go to Noza.ai, link in the description with a discount code. So we've got the model into production, but the question is it still working? So this is why we need to monitor the model itself. So we might have 90% accuracy at the time of deployment, but over 3 months we drift to 75. What happened? Well, the model didn't break. The world just changed around it. So without monitoring, we're not able to actually notice this drift in the model from where we actually launched it to where it is now after several months in production. There are 3 levels of monitoring. You have application metrics, which are uptime, latency areas. Is the endpoint actually responding? And we use CloudWatch for these. Is the model quality still where it needs to be? The accuracy, the precision, the recall. Have we drifted from our original set of baselines? And we need to set this up ourselves and use Model Monitor to do this. And then we want to look at data/concept drift. Data drift. Did the input data we're now using in production change from when we trained? And if so, do we need to retrain the model? And if we don't have detection of that data drift, then we'll never know. And concept drift is the inputs and outputs, that relationship between the inputs and outputs changed. We're predicting customer churn, but due to a change in the business, churn patterns shifted. Do we need to retrain that model? And the question is how do you detect each one of these for the exam? So application monitoring, we'll use CloudWatch to actually set up dashboards, alerts, monitors throughout, and we'll actually do that in the demo. So when we're talking about infrastructure and endpoint health, not model accuracy, you should think CloudWatch. So in this example, latency, CPU, error rate, invocations per hour, and we'll build a dashboard like this in the actual hands-on practical part of this section. When it comes to model quality though, it's different. For model metrics, you do need to know more stuff. You actually need to know ground truth levels. You need to know if you're selling houses, what did the actual price of the house sell for after your prediction, so you can compare the prediction to the ground truth. And this is what SageMaker Model Monitor does. So you can see here for the exam tip, I'm saying Model Monitor needs ground truth, no labels equals no accurate tracking. So data quality detects anomalies in the data. Model quality tracks the accuracy of the model. Bias drift, you're looking for drift in the bias, funny enough. And then feature attribution, track features, important shifts. That's your SHAP values. But you cannot do it with any of this unless you start feeding in the afterthoughts of the correct data. That's really, really, really important. Data drift, obviously extremely important to look at. This is where your inputs change, but your model logic is unchanged. So if before in training we had 25 to 55 and the mean was 38, and then in production we actually had 18 to 70 with a mean of 28, then our data has drifted from our training to production. Income, you can see, has shifted, and the region of where we're looking at has shifted as well. So we need to then go back and actually retrain this model on data that looks like more like production. But when we're monitoring the data, we're using things like the KS test, the PSI test, model monitor, and custom strips to actually look at the changes in the data and detect this. Concept drift is where the relationship between the inputs and the outputs change over time. So in the customer churn prediction that we use, low usage likely to churn, high usage likely to stay. But after we've actually launched the model, our competitor put in a free tier and high usage users now leave too. The old pattern no longer holds. You need to detect that this drift has happened with the competition lift free tier, and then eventually you'll retrain that model. So you can see here that data drift versus concept drift. With data drift, we're actually looking at the data changing over time, and this is how you detect it. And with concept drift, we're looking at the actual concept. The inputs and the output relationship have changed over time, and we need to re-engineer the features or look at new data and retrain the model that way. So, SageMaker Model Monitor, this is how it works. You need to give it baselines from your training data, so that you need to give it what normal looks like. It then captures data from your endpoint, and then over time, it will actually detect the drift, the statistical drift from the baseline to what it's seeing in production. And when the drift happens, then you send out an alert. You can look at 4 things: data quality, model quality, bias drift, and feature arbitration. Now, I said again, you need to give it baselines. So it's important you give it what normal inference looks like from your training data. Then over time, you capture it from your endpoints, and then you detect that drift through. And that's how Model Monitor works inside SageMaker. SageMaker Clarify can also be used to detect bias drift, explainability, and model monitoring or drift monitoring all in one service. It looks at pre-training bias. So did you get bias before you trained? Post-training bias, is there bias after you've trained? And then ongoing monitoring for production as well. So this is the little slide that always kind of helps with the exam preparation. You need to look at this. Model accuracy dropped from 90% to 75%. You want to investigate the drift. Input feature distribution shifted significantly. That's data drift, and you need to retrain. Same inputs, different outcomes. Concept drift, what you're looking at no longer makes sense. Endpoint latency spiked to 500 milliseconds. CloudWatch alarms. Need to track model accuracy over time. That's how you model the monitor or use model monitoring inside SageMaker. Detect the bias drift across protected groups such as male and female. Then you use SageMaker Clarify. Again, these are things you just need to learn for the exam. I think what the most important thing to take away from this is when you're looking at this slide here, application monitoring is done in CloudWatch. Then you can look at actually using the ground truth labels to detect model drift over time. And then you have model monitoring, SageMaker model monitoring to do baseline capture. So you look at the baseline and then you capture it. And then over time, you detect the drift from the endpoints that you're hosting on. And that can look at data quality, model quality, bias drift, and feature arbitration. And then our old friend SageMaker Clarify comes back into this as well. And that's your key takeaways. So 3 monitoring layers. You've got application, model quality, and data/concept drift. Data drift is where the inputs change. Concept drift is where the input and output relationship has changed. Model monitoring on SageMaker is where you do baseline, you capture, you schedule, you detect the drift from the baseline, and you alert. Ground truth labels are required for model monitoring quality. That makes sense. So if you predict house price outcome, you need to know actually what the house sold for long term, so you can feed that back in and see how accurate your prediction was. Clarify handles bias detection, explainability, and ongoing model monitoring drift. And the exam pattern, accuracy dropped, investigate drift, retrain or re-engineer the features depending on what you're doing. So re-engineering features versus retraining the model. Okay, so this is the model monitoring script. There's a bit of setup work that we're going to have to do in the end, including giving our endpoint name that we need to use for this. Again, I haven't tore down my infrastructure yet, so I can use the endpoint that we have. We're going to initialize the clients for this, and then we set up a baseline for our data. So we basically say what good looks like for our data. And then, I'm going to scroll down, we say we're going to monitor every kind of hour on what's going on, and then we have some outputs of those monitoring results as well. Again, so For the exam, it's really, really important that you understand how the monitoring works. This script goes into a lot of depth, some of it important, some of it not so important. For the purposes of this setup, I'm actually going to pause the video because by now we know how to input these values. So you input these values and then pick me back up when you go. The only one, sorry, you may not know how to get is the endpoint name. So if I go back into SageMaker, I go down into my deployments, I go to my endpoints. We want the real-time inference one, probably might be the easiest. So that's your name there. I still have them running from before. Copy it into the script. The rest is exactly the same we have been doing before. So just go get all the bucket names replaced here and the role ARN. Okay, so once you've done the replacement yourself, again, nothing new, bucket name went in. I showed you how to get the endpoint name. Same as always, just copy this into the notebook we've been using the entire time. Come down, and then we want to run that code. So this is running, and for the purposes, I have created just some dummy code so we can look through this quite quickly without having to wait in the entire script. We set up the data capture configuration. So this is where we're trying to do the baselining. So baselining, again, just a conceptual walkthrough of how this works. It creates a statistics.json file that gives us like what good looks like as the baseline. We then set up a monitoring schedule. So we're saying the schedule's on a cron job and we're going to look at it at X amount of time. In this example, it's every hour. We then look at the model execution review. So we look at actually when it happens, and then we look at the quality of the drift. So we're looking to see when the model goes away from the baseline. And if it does, we notify the ML team. So we're looking at that model drift. So what baseline looks like, and then how we drift away from it. That's what this script does. It tells you here exactly what we're doing here. On how to look at it through it. So for the exam, you will need to know about model drift. You will need to know that SageMaker lets you do model drift. You will need to know that you have a baseline and then you detect how you drift from that baseline. The script again has more detail. If you've got time, look through it, but at the very minimum, read this printout. Okay, next we're going to do inference recommendation again in that monitoring folder. A couple of things that it covers in the exam. You will need to know, this comes up a lot actually, model registry. You need to have the model registry as a prerequisite for inference recommendation to help or to work. That always comes up. You need to know that it looks at right sizing, so it looks at cost, latency, and throughput, and then it lets you know that you can load test as well. This is quite an expensive script to run, just so you're aware, so it does cost a lot to run this and get it working. I'm not going to run it for the purposes of this lesson, because for the exam, you just need to know that you can have an inference recommender. You need to know you need the model registry, and you need to know that it looks through different instance types that you put in. If you have time, read through the script. Again, my recommendation is not to run it because it does cost a lot and take a lot of time to go through, and there's a bit of config work involved as well. But you can see here, I think the important things is like I am specifying the instances to test. This includes GPU instances. So a word of warning again, don't run this script, it costs a lot. But essentially we're looking at values of what we would want to run, how we'd want to trade that off with latency. And then at the end, it prints out exactly what it looks like in terms of the educational guide to select by instance type. So just read it and make sure you understand what it is and why you would use each type of instance. But again, don't run this script. It costs a lot of money and time. Okay, and then finally in this section, we're going to take a little look at the CloudWatch dashboard that we talked about. So CloudWatch is that single pane view that you can actually look through. Again, you don't need to run this script if you don't want to. I'm just going to show you how to do it very quickly. So you would go into CloudFormation. This is a brand new stack where you want to then go stack actions. Oh, I'm in the wrong, create stack with standard resources from a template, upload the template, choose. Then you need to go back out to your downloads from the other day. We go into monitoring and then we go into the CloudWatch dashboard and we click open. Okay, and then next you want to give this a name. So we'll just call this MLL stack monitoring. Now, endpoint name, that's really important that we change the endpoint name to what we have. So back out to SageMaker under endpoints or deployments, endpoints. Pick an endpoint you want to monitor. It doesn't really matter. This is just a demo, so we'll do this one. Back in to CloudWatch, which is way over here. This, and then just an alias for your CloudWatch. So johnny@johnnychivers.co.uk. Hit next. Then hit next. And then hit submit. And this will go start creating our CloudWatch dashboard that we need. This will include all the things that the script talks about. So if we go out to the script, you'll see that we'll be looking at invocations, model latency, overhead latency, errors to the model, CPU usage, and any custom alarms that we're looking at, which is high latency and error thresholds. Again, you don't need to run this script. I'm just doing it for the purposes of this demo. The important things to know is that you can create CloudWatch metrics to monitor your models. That's the key takeaway, and we can look at things like latency, we can look at things like invocation, we can look at error rates, CPU usage. That's the important parts for the exam. You will not need to know the CloudFormation code inside out. You will be asked things about CloudFormation, so it is good to take some time and read through it. But again, don't worry about running all this code if you don't want to. So while this is often creating, you will, if you enter your email address, get a notification that you're subscribed to the alarm alert for the serverless endpoint. This is coming from our dashboard. So when our dashboard has an alert, we'll now get an alert on our email. And this is how you start to set up those production pipelines that we spoke about in the theory. So this is really monitoring the models. So when there's drift or there's latency or the CPU becomes consumed, we get notified and then we can go fix it. I'll pause this again and I'll pick it up once the CloudFormation has ran successfully. Again, you don't have to run this code. You can just watch me. Perfect. So back out on stack info, that's the stack completed. There won't be much there because I'm not using the endpoint right now, but if we go to CloudFormation and we click here, or not CloudFormation, sorry, CloudWatch. If we go to CloudWatch, click here. On the left-hand side, when it loads, we'll have dashboards. You can see here we've got everything is okay in our alarms. Yay. So that's really important. But if we go dashboards, we have our SageMaker dashboard. We click into it. Again, not much going on right now because I'm not invoking anything, but you can see this is what it looks like. So you actually have to make a request to start things, as you can see. But we've managed to make a dashboard that you can see what like utilization looks like inside the resource, how our P99 latency happens within 5-minute aggregation, container overhead, things like that. And then again, as I showed you here, we're subscribed. So when something goes wrong, we get an email message. Again, you don't have to run this. It's just important to know that you can create a dashboard. You can monitor things at your SageMaker endpoints. You can do this by endpoint. You can group them by endpoints and use this as your one window pane view into how your SageMaker model is performing. If you've ran this code, make sure you delete this code through CloudFormation as well, because you don't want it costing you anything. So if I do CloudFormation and I go into the stack, which is here, and then I hit delete stack, that will delete that stack for me. Okay, now you're more familiar with the concepts in Domain 4, bit of hands-on, bit of practical. Let's jump onto the computer and look at some questions provided by Noza.ai and how you can answer them in the exam. Again, my advice, pause as soon as the question arrives, read it, then unpause. I'm pretty quick between the slides just to keep the video time down. Domain number 4, monitoring and operational excellence. Again, sponsored by Noza.ai. Try it down below for free. There's also a discount code for the monthly sign up, and you get more exam style questions with detailed explanations like this. Your production model's accuracy has dropped from 90% to 75% over 3 months, but the code hasn't changed. What should you investigate first? Pause the video. That's right, you need to check for data drift because the input distributions may have shifted. That's the data drift we talked about in the last section. The same inputs that previously predicted, question number 2. The same inputs that previously predicted approved are now predicting as deny, even though the input distributions haven't changed. What type of drift is this? Pause the video. That's right, conceptual drift. Why? Because the input distributions are stable, but the correct mappings have changed. Question number 3. You need to continuously monitor a deployed model for bias across protected demographic groups. Which AWS service should you use? Pause the video and think about it. That's right, SageMaker Clarify provides scheduled bias monitoring for production models. And the last question in this section, your endpoint latency suddenly spikes to 500 milliseconds. No model changes were made. What type of issue is this and which service alerts you? Pause the video. That's correct. You have an infrastructure issue using Amazon CloudWatch where you can see latency. Again, these questions and more like it can be found on Noza.ai, who are sponsoring this video. Link in the description and the code for discount for the monthly sign up as well. So for the exam, it's important to know if your ML pipeline is protected end to end. Security tells you if the model is safe. So these are the different dimensions, I suppose, of security and machine learning that you need to know for the certification. We need to know about network security, VPC isolation, subnets, no public internet for sensitive resources, including SageMaker. Encryption at rest and in transit comes up in all AWS certifications, nothing different here. Data residency that we covered before, but GDPR and HIPAA compliance, does the data stay in the required regions? IAM, least privileged access, who needs data for each role and service? Audit logging and model governance as well. So exam tip, PII scenario, personally identifiable information such as name, date of birth. You're going to need an encryption. You're probably going to need a VPC isolation. You're going to need IAM for least privileged access, and you're going to need CloudWatch trail logging as well. So this is what a VPC network isolation looks like. There is code in the repo if you want to go look at this. I'll not actually deploy it myself, but there is code. This is where you create a private subnet in a VPC around your SageMaker resources that you're using. It can then use endpoints such as gateway endpoint, ECR endpoint to reach out over private backbone to S3, ECR, and CloudWatch. So it's private link for API access, VPC endpoints for S3, ECR, and CloudWatch. There's no internet gateway at all in this, and you deploy SageMaker in private subnets. Exam tip, VPC isolation is number one for network security control of SageMaker. This does a question that comes up in the exam a lot. Can I isolate my resources away from the internet? And the answer is yes. In SageMaker, I can use VPC isolation. This is what IAM looks like. You probably are familiar with it if you're doing an associate level exam, but I put some of it onto the slide just so you can look at it. So you can see here that we're doing resource isolation in the S3. We're working off least privilege because you can only get to this S3 bucket. We're not attaching admin to this role as well. What's the most important? IAM control, least privilege for executions with specific resource ARNs. Encryption, again, should be fairly familiar with it, but it's important from the security point of view. Encryption at rest, encryption in transit. The use of cluster manager keys, AWS managed keys, maybe even HSM will come up in the exam. So it's important that you know what can be encrypted and how to encrypt it. And encryption in transit, then you can use TLS for all API calls, HTTPS to access SageMaker Studio as well. And again, use KMS keys for encryption at rest, enable encryption inter-container traffic for transit. So there are important things that you need to enable and know for the exam. It's standard encryption. Make sure you know this slide when you're going into the exam itself. Then so you're aware for audit logging, CloudTrail, which monitors the API calls in the cloud, and in this case SageMaker API calls. You'll want to track all those. So you'll want to turn on logging and encryption, and then when the logging happens of these cloud trail calls, you'll be able to screen them afterwards. Then we've already covered this, but I'll just put it down. So compliance and data residency. So GDPR, HIPAA, PCI DSS for processing payments, and SOC 2 for enterprise data and controls. It is important that you will need to know these for the exams. Again, GDPR, does the data stay in the EU? HIPAA, does it hit all the qualifications for the healthcare data? And how are you making sure that you are sticking to the requirements of compliance? Model governance is becoming larger and larger and larger of a topic, believe it or not, over time. This is about how the model registry can be used to actually train, evaluate, register the model, then approve the model from a pending state, and then deploy it. So you can see here, you can go from pending, manual, approved, approved, and rejected. This comes up in the exam quite a bit, as does the version tracking of the model. So if you have a SageMaker pipeline and you're constantly retraining the model, then you can keep versions of the model as they are. And again, exam practice for the security, this is what you need to be thinking about. You have an ML pipeline processing customer PII data, where you're going to need to think encryption, VPC, and IAM need to be there. Prevent SageMaker from accessing the public internet. Well, you can use VPC, a VPC with no internet access, and block the public endpoints. Track who deleted a production model. Well, CloudTrail will do that for you. EU customer data must stay in EU West 1. Well, you have to use region pinning, and then maybe service control policies from an organizational standpoint. Only approved models should be deployable. Model registry. Execution rule has too many permissions. You're not working to least privilege. These are the mental models you should have in your head going into the exam. And then key takeaways: VPC isolation with private subnets and no public access. You should definitely know that. IAM should always work off least privilege. Encryption at rest using KMS and TLS for in transit. CloudTrail logs let you see every API call, who made what, when, where for an audit trail. Compliance, you need to be recognizing GDPR. And then the model registry governs the deployment. So it's important to know these facts as well when it goes into the exam. Now you're more familiar with security on domain 4, the kind of final topic that we're looking at here. Let's look at some exam style questions. Again, word of warning, I'm pretty quick through the slides, so pause as soon as the question arrives, read it, then unpause. This is just to keep the video time down for me. Security, governance and compliance, sponsored by Noza.ai, where there's an AI learning powered assistant when you help you go through AWS practice questions. So again, link in the description, and there's a discount code as well for the monthly sign up fee. You do get 10 free questions as well when you sign up for the first time. It's a great resource to help you pass AWS certifications doing exam style questions, but with a feedback loop using an AI powered assistant. And on question 1, your security team requires that SageMaker training jobs cannot access the public internet. How do you achieve this while still allowing access to S3 and ECR? Pause the video. The answer is deploy in a private subnet with a VPC, endpoints for S3 and ECR. Next question. SageMaker execution role has SageMaker star and S3 star with resource star. What is the main security concern? Pause the video. That's right, it violates least privilege and grants access to all S3 buckets. Question number 3. You need to encrypt data at transit between distribution training nodes and in SageMaker training jobs. Which parameter do you enable? Pause the video. Mark, it does what it says on the tin. It encrypts traffic between the container nodes when using SageMaker. And finally, EU regulations require that customer data must never leave the EU. How do you enforce this across your entire AWS organization? Pause the video. That's right, apply a service control policy restricting regions at the org level, SCP. We didn't go into too much depth in the video about SCP organizations. You may want to look at this separately. But again, for more exam style questions like this, please visit Noza.ai, link in the description with discount code. You'll get exam practice with an AI learning assistant that will tell you more detailed explanations as you go along to questions that are in the style of the AWS certification of your choosing. That's Noza.ai. Right, folks, that's pretty much us for today. Make sure you delete all the CloudFormation code. Make sure you spin down all these resources so you're not paying for it. It costs between $3 and $4, as I said throughout the video, in order to run this, if you do it in one sitting. So just make sure you spin everything down. Big shout out to today's video sponsor again, Noza.ai, for all those questions and helping us get better for the AWS exam preparation. Link in the description below alongside the discount code. And don't forget as well, if you want the slides and the revision guide, link below that you can sign up for those as well. And finally, folks, best of luck in the exam. You've got this. With this information and all the other information available out there, I'm sure you will ace the exam. Let me know how it goes in the comments. And until next time, thanks for watching.